Hello everyone, am I audible? Am I audible, people? Yeah, cool. Yeah. Welcome back, everybody. Today we have the fourth class of high-level design. In the last class, we discussed about caches. We discussed about different types of caches, and we discussed very extensively about caches and a few other ancillary things in the last class. In today's class, we are going to utilize our information of caches and understand how caches work and utilize that information in designing a system which is a very popular system, which is called as a Facebook news feed. Okay, so we would want to utilize our knowledge that we gained over the last few classes and see what kind of design decisions do we have to take and and what to build this kind of a system. Okay, so how many of you are aware of a Facebook news feed? Everyone would be, right? So what is a Facebook news feed? That you are everybody of almost every one of us is a Facebook user. You actually log into your account and you are provided with a feed, right? You see a list of posts. Okay, and that list of posts is specific to you. Okay, so what is the problem statement that we have? You when a user logs in, he or she should be able to see a list, or actually it's basically a sorted list, right? It's a sorted list of posts that is specific to you, right? That is specific to the user. Is it only specific to the user, or is it specific to something else as well? Does it depend only on the user, or is there some other moving part as well? The other moving part is the time at which you are accessing the feed. Does that make sense? Your feed does not remain static, right? Your feed would be different today, would be different 10 minutes down the line, 2 hours down the line. Tomorrow it will be totally different, right? So it's not only about the user, but it's also about at what time you want to see that feed. Okay, so yeah, so what exactly are we trying to do? We are so in the classes going forward, I'm actually going to describe it to you a very set pattern of questions that you should ask yourself. Just a minute, let me just mute my Slack notifications, and otherwise this would keep on bothering us. Just a minute. Yep, done. Yeah. So in the next few classes, we are going to see a very set pattern of questions that you should ask yourself in designing a system. Today, I'm skipping that because I would want to focus on something else. I would want to focus on understanding the problem in a very in a very fundamental manner. Okay. So whenever a problem comes to you, these are the fundamental questions that you should ask yourself that we are discussing today. How to approach any given problem in a set of questions, that is what is relevant for the interview, we are going to discuss in maybe the following classes. Okay, so today let's see how I am actually looking at the problem, right? So I am first of all seeing that yes, it's a news feed which is dependent on what user accesses it, right? So you cannot have a news feed which is, let's say, common for a group of users. Okay, so it's a news feed is specific to a user, and it's also time sensitive, right? So it's based on what time you're looking at, right? So it cannot be a static resource, right? It needs to be something which keeps on updating dynamically. Are you guys able to understand that? Right, so this is the first thing that you should understand. Now let's try to understand where is this data coming from, right? What populates the newsfeed? So what populates the newsfeed, people? So this is the first thing that we discussed. The second thing is what populates the newsfeed. So this is how you want to see the data. How is actually that data being populated, right? So yeah, how is it generated? So it's generated based on the posts that are happening around. Does it make sense? It's generated based on the posts that are happening around, right? So based on the posts of, let's say, your friends, right? People you follow. Let's say there can be a celebrity or a movie, or let's say a cricketer or something who you are who are you are following, and you want to see what they have posted. So about from your friends, from your people that you follow, let's say from the pages that you follow, or let's say some news, basically there is some topic that you are following, and so on and so forth. Does it make sense, people? And maybe some advertisements. these are the way your feeds are generated. Does it make sense, everybody? Does it make sense? Yeah, cool. So this is how your feed is generated. So we have discussed about that when a user logs in, you want to see the post, and when based on what your friends have posted or your people that you are interested in have posted, your feed is generated, right? So these are the two moving parts that we have discussed till now. Okay, now let's actually try to approach it using how we are going to save this data. Okay, let's try to now see how we are actually going to save this data. Okay, so first of all, does everybody in the class agree with me that there should be some mapping of the user ID to post, that what user has posted what? Does everybody in the class agree that there should, no matter what design you come up with, there should be a user mapping to post mapping? Is there anybody in the class who feels this can be avoided? We can not store that, the user ID to post mapping? We cannot, right? We must store कि अच्छा this user has made this post. Okay, so this is something that we all agree on. This is a must, right? Now let's say, let me tell you another piece of information that is a must according to me. That is that user ID with the mapping of all the friends that you have. Is this also a must, no matter how you design it? Right. So these are the two very, very fundamental things that you must store at the back end, right? So that you can do whatever you want to do with the system, right? So now let's try to appreciate that why this is a big, big data to be stored. Okay. So now, first of all, let's estimate how many users do Facebook have? Okay. So can you guys come up with a rough estimate? How many billions, right? So Facebook has billions of users. So let's assume Facebook has 2 billion users. Okay, this is the first, right? So isn't the privacy setting important? Okay, Aditya, we will be discussing that. So Aditya, let me just give you a quick peek view into how a system is designed, how you solve systems in a yeah, Bishali, I'm coming to that. Aditya, let me just give you a bird's eye view of how what questions are you going to answer when designing a system. So first of all, you are going to discuss some features that you want to discuss. So privacy setting, managing your privacy setting can be a feature that you want to have in your system, but in most of the interviews you would want to start with a minimum viable product. Okay, what is a minimum viable product? A product that is the minimum thing that you must ship to get it functional, right? So in most of the interviews you actually decide on a few set of features which forms your minimum viable product and define your design based on that only, right? So at this point in time, do not let's assume about everything that can be done. Instead, let's focus on some basic things. Going forward, we are going to discuss a lot more ancillary things as well, right? So first of all, yes, there are 2 billion users for Facebook. Now, this is not the information that gives, this is not the piece of data that gives us all the information about Facebook, right? The other very, very important piece of information, as Vaishali rightly points out, is daily active users. Okay, so you know these are the number of users that you have. How many daily active users do you have? This is a term which is called as DAU. You're going to see again and again in all the HLD classes. Okay, DAU, daily active users. What does that mean? That actually means that on any given random day, how many active users, how many users are going to log into your platform and do some actions. Does it make sense what daily active users mean? I'm not saying that only these set of users are coming day in and day out again. I'm just saying on any given random day, you can assume, yeah, you can assume that these many users would log into your system and do some activity. Okay, so overall, Facebook would be having roughly around 2 billion, 3 billion, 3 billion accounts, and daily active users that Facebook would have. Vishali's in talking about the correct ballpark figure. I would say maybe it's 400 million, but yeah, 200 to 400 million, you can safely assume that this is what you have daily active users. Does it make sense, guys? People, are you with me? Cool. So now we know that these are the daily active users that you have. Now let's come back to the data that we decided that we must store, right? No matter if you store this on a SQL box or a NoSQL box. The folks who do not know what NoSQL is, do not worry at this point in time. Let's assume we are storing this in a SQL box. The number of daily active, the number of users that you have 2 billion. Now look at the size of any one of these tables. So let's look at this table size. Do you appreciate that this table, the number of rows would be 2 billion? Do you guys appreciate that? The number of rows in this table would be 2 billion, right? For every user, you would want to have a mapping of friends that you have, right? And let's say the average number of friends that anybody can have is, let's say, what would be a good average number of friends? What would be a good average number of friends? 5,000, 2,000, 1,000, 150, 500. Okay. So we now see how friendly all of us are. At least friendly on social networks, right? So okay, so I would say that maybe the average would be around 1,000, if I'm not wrong, maybe 1,000 friends per user. And you can say that at most Facebook can actually define a limit and say that I will not allow more than 5,000 friends, right? So Facebook or these social networking sites do enforce a limit, and we're actually going to see that down the line why we are actually going to see that down the line, that why those limits are enforced. But let's assume that at most 5,000 friends would be allowed at most, and on average, let's assume 1,000 friends on average. Does these numbers look fine to you guys? Cool. So we have the table which is for friends, that is user to friend mapping. For this table, we see that we have 2 billion rows, and we have, let's say, 1,000 entries for every table. Does it make sense? Now this is one table. Let's look at the other table that we discussed, which is the user ID to post. Okay. So how many rows would be there in user ID to post? In the table user ID to post, how many rows would be there? 2 billion, right? Again, 2 billion, because there are 2 billion users. Now, how many posts per user would be posting, a user would be posting in his lifetime? That's a bit difficult to estimate. We are going to do some calculations going down the line, but let's for now assume that every user would be in a lifetime would be posting something like maybe per day is 10 posts per day, or maybe less these days, because we have actually moved away from Facebook. But yeah, if you remember the good old days of Facebook, when all of us would be very active on Facebook, we would be maybe posting 3, 4, 5, 6 posts every day, right? So over a period of time, and right right right. So I would be saying, I would not be shocked to say that maybe every user would have posted around 3, 4,000 posts in their lifetime. Maybe if you want to build a system for 10, 20 years, maybe this is a good number to estimate, that yes, you would want the number of entries per user would be, let's say, 3, 4, 5,000 or something like that. Now, even if you do not consider the number of posts that you see, do you understand that these tables are too big to fit on a single box? Does everybody in the class appreciate that these tables are too big to fit on a single box? Why is that the case? First of all, you are going to you cannot probably have a system which is going to have this much storage capacity, right? This is not possible. Even if that was possible, would you want to have one system where you're going to maintain all the connections to 2 billion users? Let's say you want some data for the user X and it, you would maintain a same connection to the same DB, and you want you wanted some data for the 1 billionth user. Again, you would want to connect to the same DB, so that's not possible, right? First of all, practically not possible to have a DB with this amount of storage space. So this table cannot be placed on a single machine. Does everybody in the class understand that? These tables that we just discussed, these tables cannot fit on a single machine. Right. So these tables cannot sit. Okay. So any good estimate of the size allowed on MySQL storage? So we would be discussing, we would be taking a small session on estimates, but for now you can assume that maybe a few uh, a few hundred GBs would be something that is available all around, right? That is a very simple. You have a laptop which is having 500 GB or 1 TB storage. So boxes would generally be of the order of, let's say, 20 TB, 40 TB, 60 TB, something like that. Okay, you can have boxes which are going to have higher storage as well, but let's just wait for a class in which I will be doing some divisions and telling you that this kind of a box would have this kind of a storage. Does it make sense, Uncle? Cool. So these tables can't sit on a single machine. This is what we all know, right? So we are going to spread this across multiple DBs. So yes, we are going to have multiple DBs to store this data, first of all. Now, the moment you have multiple DBs to store any data, do you understand this is called as sharding? You shard your data. So every piece that you have is called a shard. So this would be called a shard. And this entire process of splitting the table in a horizontal fashion. So you have every single column for the same tuple in one DB only. You are not dividing the columns across different DBs, but you are dividing the rows across different DBs. Does it make sense? So I have, if you look at a SQL DB, I've just divided based on rows, and there is a collection of rows that is sitting in the first DB, collection of rows sitting in the second DB, and so on and so forth. Does that make sense to everybody? Okay, cool. Now, once this makes sense, everybody's on the same page that yes, we must shard our data and we must have our data across multiple boxes. Let's now come to the good old diagram that we have always been drawing and see how things actually shape up in that diagram. Okay, so what you have a client to begin with. Your client interacts with the load balancer. Before that, you would be actually going to the DNS, get the IP back. You have a load balancer now. Load balancer is going to do some magic and it's going to connect you to one of the app server boxes. And then app server boxes are then connected to the storage layer. So Moe says shards never share tuples amongst themselves, right? Okay. So are you saying that you have one tuple, which, okay, some noise. Is it better now, Sukanya? Is the noise better? Is it still there? Is it better? Right? It's better. Right? Cool, cool, cool. So Moise, so what happens actually? You can actually have two shard. You can have a single shard sitting on two different boxes, but that is something which we call as a master slave architecture, or we call as replication strategies. Do you understand that, Moise? So we did discuss slightly the duplications and the replication. So you can actually have a group of shards accessing a group of boxes having the same data, but you are not going to. But from a serving point of view, let's assume that every shard sits on one single box. Okay. So do you want me to unmute you, Moise? I did not get what exactly do you mean. Sure. Yeah. Hey, Moise. Hello. Can you guys hear Moise? No. Moise, I also cannot hear you. Is you have been unmuted, वैसे. Cool. So Moise, let's actually get back to this later. I think there is some issue at your mic at your end. So let's actually get back to this later. Sukanya asks, this diagram is like a standard one for all the high-level design, right? Yeah. So this is a bird's eye view of how the system actually any system is actually made, but how are the interactions happening? What thing stores what are the trade-offs that you have taken into account? This is something which totally depends on what problem that you're solving, Sukanya, right? Cool. But master slave architecture can work here. If yes, then how it will work? Okay, so let's not go in master slave architecture for now, because that would be a big digression. Let's wait, and if you still have some questions, we can actually answer those. Okay. If not anything, we can draw the diagram. Of course, Sukanya, you can draw this diagram in any high-level design interview, but that would not be sufficient, unfortunately. Cool. So client, DNS, load balancer, we have the app servers, we have the storage layer. Okay. We just discussed that we are going to shard our data across these boxes and the data would be spread. Now you tell me. So this is done for the storage part. Now you tell me, do I actually require more than one app server boxes as well? Would a single app server box do? It won't, right? It won't. So single app server box won't do. You will actually have to maintain multiple app server boxes, primarily for the same reason that you have so many number of users, and you would want so many number of requests, you would want to parallelly be responding to those requests. So that's why you would definitely want to have more than one boxes. Let me tell you about Facebook. Facebook generally would have let's say boxes of the order of, let's say, 5,000 to 7,000 boxes running at any given point in time. Okay, so you would see a lot of boxes who are going to be serving those requests at any given point in time. Cool. Now, do you think a stateless box will help here, or would you want to have a stateful box? You guys tell me. Would you want a stateless box, that is any user can go to any box, or would you want to actually have, let's say, a user mapped to a single box, right? So I am pretty happy to see that almost unanimously the entire class agrees that it should be some kind of a stateful system, right? So you should have a group of users sitting on every being served by every single box, and similarly you should have a group of users sitting in one of the DBs. Does it make sense? So it's a state. So you have actually sharded your data across multiple DBs. At the same time, you have actually introduced multiple app server boxes so that the computations that you do are also spread out, and these are stateful boxes. Does it make sense, everybody? So you just simply have a consistent hashing here, and the consistent hashing will be based on user ID. Does that make sense? What would be the key for consistent hashing? It would be user ID, right? So what determines the key of consistent hashing? The key at which you would want to divide your data actually determines your consistent hashing, key of consistent hashing. Does that make sense, everybody? It does, right? Cool. Now we are done with the very basics, and now let's actually see. Let's actually assume that we do not have any cache at this point in time. Okay, let's assume that I do not have any cache at this point in time, and I would want to figure out, no matter how slow that process is, I would want to figure out several ways of multiple ways in which I can actually get this entire thing done. Okay, so what do I mean by that? I want to now figure out a way of how am I actually going to generate a news feed for any particular user. How is the data actually going to be moved? Okay, so let's first of all try to look at how I would be getting a news feed. Okay, in the following classes, I'm actually also going to discuss how to design an API, right? So we are going to be designing APIs, and for every API, we are going to design a path flow that how the data moves and where all the storages are happening, what all computes are happening. Okay, so did you guys actually see the API design in your low-level system design classes as well? So Kshitij, you would have taken those classes. Oh, okay. So you guys did not discuss API designs? Okay, okay. So we are probably going to discuss that thoda sa more detailed in high level design classes if we did not discuss those in low level design classes. Cool. Anyhow, so for today, so the charter of today's class is to give you guys some sense of how systems are designed and to give you some sense of how to utilize all the information that we discussed. In the following classes, we are going to follow a much more structured way. But today, let's see. So, okay, get news feed. So you are going to pass a user ID that for this user ID, I want to get a news feed. Does it make sense? So you are definitely going to pass a user ID. Can you actually think of some more parameters that you're going to pass to get the user ID, to get the news feed for a user ID? Assume that authentication was already done, or if authentication was not already done, then you can just have an authentication code or a password, something like that, which will authenticate that yes, this API, this user is authenticated to make this API call. Okay, cool. So there should be a user ID, there should be an authentication token, right? So people says there should be time. Okay, so let's just wait for time. There should be friend IDs. How many of you think I should be passing friend IDs here? How many of you feel that I should be passing? Hey man, I have these 2,000 friends. I am passing those friends IDs to you in the API call. Give me the data. Right? That's not required. Right? In fact, understand who is making this API call. People who is making this API call. The client is making the API call. Right? If you look at this diagram, who is making this API call? The client is making this API call. Does the client actually need to know all the friends that I have at any given point in time? Maybe not, right? Why would I want to store every single friend that I have at the client, right? At my mobile app. that's not required, right? So that's something that won't be passed in the API. You would have that information at the back end. You can figure out there who all my friends are and generate a newsfeed for me. Apart from this, one very, if it would, yeah, right. So Sukanya, yeah, you would not want to store all the friends at the app side for different reasons, right? First of all, you would not want to overwhelm the client. Does it make sense? Why would you want to store so many things which are not actually required at the client, right? Secondly, why would you actually want to introduce so much data transfer, right? So every time you are giving some information to the client, understand that a lot of data transfer is actually happening. It's making your apps run slower, it's consuming the memory of the app, and so on and so forth. So you would want to keep it as light as possible. And also, maybe you would not want to make it that simple for the client to utilize that data and do something with it, right? You would want to keep as much aggregated data at your end and only give as much usable or required data at the client's end, right? It should not be the case that I am designing a system, but I am sending every single, I am actually passing on every piece of information to the client. That's something which is not required. Okay. Okay, Lokesh, we are going to come that. Now, one thing that is very much required, which Beshali has pointed out multiple times, is the parameters that you would want to have for pagination. What is pagination? Pagination actually means that, first of all, you guys tell me, can you actually assume that a single API call is going to give me the entire timeline that I have or the entire newsfeed that I have? Right. In Facebook case, is newsfeed of a constant length? No. News feeds in Facebook's case are infinite, right? So you can actually keep on scrolling, keep on scrolling, keep on scrolling, unless you actually go to a point where unless until you were that free, right? So you are going through that lockdown period, you don't have anything to do, and you just want to keep on scrolling and test the limits of what all information can Facebook show you. Unless until that happens, this is, well, you do get a feeling, perceived behavior of any newsfeed is these days that it should look infinite, right? The newsfeed should look infinite. So one single API call is not going to give you all the data, that's for sure. The moment that happens in any system that happens, pagination is something that you want to do. What is pagination? You want to tell the system that, hey man, I want this page of this data, right? This is a very crude way of saying that. In other words, you would want to tell them that, hey man, this is the offset. So I have the information till this point in time. I want you to give me the further information from this point to this point. Does it make sense, everybody? Right. So one way of doing this, right? How much response payload is too much payload? Okay. So I'm actually going to look that up and look at some average numbers, but the payload should never be too big. The the payload also, okay. So I will get back to that. The payload should primarily be, business, I will repeat, so it should primarily be of the order of a few MBs at the worst case, but I will come back to that to you guys in the next class. That's a good question to ask. Okay, so I will come back to that question in the next class. That what are the average numbers of all the payloads all the API calls that we see these days, and what are the average numbers, what are the good to have numbers. Okay, cool. Right. So we were discussing about pagination. Okay, so Suhail wanted me to repeat pagination. Suhail, do you want me to unmute you? Would you mind if I unmute you? Let's have a discussion. Okay, so Suhail maybe is okay, cool. Anyhow, so pagination is that you cannot expect to get the entire data in one API call. You would want to get the data in chunks, right? You would want to get data in chunks. There comes the concept of pagination, that you would want to tell your system that I have data till this point in time. I want you to give me, let's say, the next 20 posts, or let's say I have the data till this time. You give me the data till this time, right? So these kind of systems, or let's say maintaining offsets, that I have the data till the first 30 posts, you give me the next 30 posts from 31st onwards, right? So this is what is called as pagination. There are different ways of doing paginations. You can actually just have an offset. You can just do with timestamps. You can just do with, let's say, offset comma number of posts, or you can, let's say, do with timestamp comma number of posts. So the different ways of actually doing pagination. It's just the right. So it's just based on different applications that what kind of parameters would you actually want to use to make that pagination run. Bodhitwa, is it does it make sense to what I replied? Does it make sense now, Bodhitwa? So you need not have a fixed value. It's basically something which totally depends on what kind of an application you have. So maybe some clients would have a fixed value that yes, I only want the next 20 posts. Some some would say that I do not have a limit on the number of posts that you can show me. You only enforce a limit at your end. I have just told you that I have did this timestamp. You give me whatever next you can give me, right? So maybe it's the client's, not the client's responsibility, but the server side's responsibility to do that analysis and tell you how many posts I'm going to share with you, right? So this is, both ways are totally fine. The client itself in the API call can tell that I have posted ID posts till this cursor ID or till this offset. You give me the next 20 posts. That is also fine. And for the server deciding that, that's also fine. Bodhita, does it make sense? Cool. Right. So this is a kind of a API call that we are going to see. Now, whenever some user wants to access his or her news feed, you guys tell me what should be the procedure now, right? I will help you a bit. So whenever a user makes a request to the load balancer with a user ID, the client, based on the consistent hashing, will know that what particular server is going to serve it. Does it make sense? Using consistent hashing, client would know what particular server is going to access it. So let's assume this particular server happens to give replies to this particular user ID. Now, if this particular server happens to give responses to this user ID, now what is the next step that I want to do? I want to figure out all the friends. Does it make sense? I want to figure out all the friends. For now, assume there is no cache. So if there is no cache, what would happen? If there is no cache, then you would actually want to go from this box, you would actually want to go to one of the DBs where that particular user ID is stored, and you would want to see all the posts, all the friends of that user ID. Does it make sense? So let's say from this, you make a connection to this DB, you get all the friends that user had. Okay, so let's assume you got those 2000 friends that this user had. Cool. Now you have 2000 friends. What next do you want to do? What next do you want to do? Get their posts, right? Get the posts that these guys have added. Does it make sense? So now you tell me, if there are 2000 friends and every post, every of those friends may be sitting on different DB boxes. Does it make sense? Every friend may actually be sitting on a different shard. There is no guarantee that all of them will be in the same box. Maybe one friend is here, maybe the second friend is here, maybe the third friend is here, the fourth friend is there, and so on and so forth. So you can have different friends at different locations. So what do? You now actually are going to be forced to make 2000 DB calls. Does it make sense? Let's assume there is a consistent hashing here as well, which tells you that what particular user sits at what particular box, right? If you have that information, do you agree with me that I am going to make 2000 calls to this consistent hash to see where that particular friend sits? And then from that particular so let's assume the first friend was sitting in this box. So I am going to, from the table which was user ID to post, I am going to get some posts of that user ID, and I'm going to bring it here back. Then I'm going to make the second call at the DB where the second friend sits, get some top post of that user ID from the user ID comma post table, and so on and so forth. Make 2000 calls, get all the data here, then maybe generate a feed here, and then reply back. How many of you understand this control flow? Any doubt to anybody in the class that they do not know how this control flow is working? Everybody appreciates it, right? Okay. So is second consistent hashing keys friend ID? It would not be friend ID, Sankalp. It would again be user ID, right? So friends are also users. Okay. But it takes a lot of time. That's absolutely correct, Lokesh. Let's actually try to estimate how much time does it take. Okay. So let's assume, Uze, we are going to come to that. Let's assume that 1 DB call, let's assume let's assume takes 50 millisecond. Okay, so let's assume 1 dB calls take 50 milliseconds. Now how many dB calls are you making here? So you are making 1 dB call for fetching all the friends. Does it make sense? So 50 millisecond for fetching all the friends that you have. Now you are making 1 dB call for every friend now to fetch their latest posts. Does it make sense? 1 dB call for every friend to fetch their latest posts. And if we assume that there are 2000 friends that I have, so the amount of time for this process would be 2000 to 50 milliseconds. Can somebody quickly tell me the summation of these things? So it's 50 millisecond plus 2000 into 50 millisecond. It's something like 100 seconds, which is nothing but 2 minutes. Right. We are going to come to that, Lokesh. We are going to come to that, Manish. We are going to come discuss that. So, do you agree that 2 minutes is a very bad time for any user to wait for his or her feed to load? This is totally unacceptable. This system is totally unacceptable in its present form. Does it make sense to everybody? I would want everybody to reply. Does it make sense? Are you guys with me till this point in time? Any doubt? Anything that you would want me to take up? Right. Some noise at your end. Okay, Moiz. There is some noise. Okay. Did it start just now, or was it always there? Did it start just now? Always there? Okay. While moving. Let me just maybe remove my and see if this helps. Does this help, guys? This helps, right? Cool. 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 So we have seen that yes, 2 minutes is a very bad time for you guys for anybody to wait. This is totally unacceptable from Facebook's end or from any social media's end, right? This is not possible. Now, if this is not possible, one way to improve this would be what Manish suggested. Manish said that these 2000 calls may not be synchronous. You may not have a single iterative loop in which you're going to make all these 2000 calls. Does it make sense? I can actually parallelize these requests. Does it make sense to you guys? I can actually call these requests asynchronously. Every request is going to be handled differently, and then I wait for them to accumulate the data and give me the data. Right? Okay. So Uzair, what Manish suggested, that I am assuming 2 minutes time for it to load, because I am assuming that I am going to make one call after the other. So the box makes the first call once, then it makes the second call, then it makes the third call. After the third replied, it makes the fourth call, and so on and so forth. Does it make sense, Uzair? The moment you do that, it then takes 2 minutes for you to fetch all the data. But just because these calls are independent of each other, even if you are making a call for user 1, at the same time you can make a call for user 2, at the same time you can make a call for user 3. Nobody is stopping you from doing that. Does it make sense, Uzair? And to everybody else in the class? So just because you can actually do these things asynchronously, you can do these things parallelly, the time would reduce. That's a good argument to make. But let me tell you why that still does not solve the problem, right? Let me tell you why that still does not solve the problem. Point one. Okay, Bishali, I'm going to read your long comment in a minute. Let me just complete what I wanted to say. Right. So point one would be that first of all, there would be some limit to asynchronization. There would be some limit to parallelization. Does it make sense? There will be some limit to parallelization. You cannot just assume that you are going to run every single request parallelly at the same time. Why? Because I am not the only user using Facebook. Don't assume you're the single user to be that special. There are so many users. There are billions of users or millions of users who are active every day. You cannot just say that every request is going to be running parallelly at the same time without any backlog. That's not a possibility, right? So that's not a possibility. There is a limit to parallelization. But then even if you remove, even if you do not worry about only that limit of parallelization, try to understand that even if you will get this feed a bit earlier, right? Even if yeah, if you are the only user on a social networking site, so it's maybe time for you to leave that website, right? So I do not see much point in staying there, right? Cool. Right. So we now understand that ठीक है, even if the time may reduce if I introduce parallelization, but the point is, from a system point of view, you are actually imposing 2 minutes ka access time or these many access requests in the larger system. Does it make sense to everybody? So your system is yours, right? You are the one who is handling that system, right? You want to design something for that system. If for every single newsfeed load, you are going to do a job which collectively take 100 seconds. It may not take 100 seconds on your clock's timeline. Does it make sense, people? But those, if you just aggregate every operation that is happening, irrespective if it's happening parallelly or sequentially, the time would still be 100 seconds. Does it make sense to you? The compute time or the fetch time would still be 100 seconds. Would you want to make your system face this kind of a excess load every time a news feed is being loaded? So it's totally a bad design. Okay? Even if you can introduce some parallelization and can reduce this 100 seconds to maybe, let's say 3 seconds, or let's say not maybe 3 seconds, maybe 30 seconds, or maybe let's say 20 seconds, still it's a very bad design, because you actually are imposing these many number of requests at your system aggregatedly. Okay, so this is a bad design. Does it make sense to everybody that this is a bad design? Okay, abhi tak we use this bad design to only discuss what about a get news feed. Let's also discuss the other cog in the wheel. Can you guys tell me the other very important cog in the wheel? Can somebody tell me that? Right, Beshali is absolutely right. This is basically how you read it. You would also want to discuss how the posts are actually stored, right? So what happens if somebody is actually posting something, right? What is the data flow there? Does it make sense, everybody? That's also very important to discuss, right? Cool. So now if you want to discuss the writes, let's look at it. You are a user, you want to write something. You would go to the load balancer. The load balancer will go to, using the consistent hashing, understand that which box this user is being handled at. Let's assume the user was handled at this box, and now you have some post that you're making. The post that you're making, this box will actually figure out which DB this user sits on, and will first of all add a post in that DB. Does that make sense, everybody? This luckily seems to be Vaishali, that's great to hear. I also frankly love, okay. But I also love high level design, even if you did not want me to be knowing that, but yes, I also love high level design. Cool. Let's just come back to it. Okay, cool. So from the load balancer, we actually would go to this system, and from here we would go to the particular DB where we want to add that entry. This, luckily, using this system that we have just designed, is a very straightforward thing. Does it make sense, everybody? Does it make sense? Cool. So this is a very straightforward thing to do. Now, okay. So should we discuss about, okay. So we will discuss about how to decouple posts and post storage, maybe sometime down the class. Remind me if I forget that. But for now, we understood that this is something which is not going to work. Now, I am opening this up for the class now. Take 3-4 minutes. Come up with different ways that you can solve this problem. I will unmute you one by one, and I will write your approaches here one by one. And then we will discuss all those approaches. And maybe if one of you come up with a very good approach, we are going to accept that. If none of those approaches seem acceptable, we are going to maybe discuss some other approach which may be acceptable. Does it make sense? Does it sound good? Maybe take 2-3 minutes. Okay. So the question was, Azhar, that how would you actually design this? So we see that the present design that we have, in which we are actually storing user ID to friends at different boxes and user IDs to posts at different boxes. Now the moment you want to generate a news feed, you are essentially making one DB call to get all your friends and 2000 DB calls to make get all the posts that your friends have made, let's say in the last 40 minutes, last 1 hour, so on and so forth, right? This we see is a very, very heavy task on the system. Let's actually try to introduce something in this system. Let's actually try to redesign the system or maybe add a few components in the system so that this bottleneck that we are seeing would be resolved. Does it make sense? So everybody take a couple of minutes, and then I'm going to unmute you one by one, list down all the approaches, and then we are going to evaluate each and every approach. Cool. Is everybody with me? Anybody feeling lost? Everybody with me? Yes, no? Manu is with me. Thanks. Thank you. Cool. If anybody is feeling lost, feel free to let me know. Okay, cool. Think about it. I'm just coming back in a moment. I'm just getting my water bottle. Think about it. We are going to then discuss this. Yeah. Okay, Sukanya, I will answer that. Okay, so Sukanya, can I unmute you? Let's have a discussion, Sukanya. Or would you prefer me just telling it right away? Yeah, okay, sure, I will do that. Lokesh says, cool, cool. So let me first of all take Sukanya's. Oh, okay, Moez, I take your request, but I would want to know the reason for your request, Moez. But yes, we'll discuss that. Uh, cool. So let me take Sukanya's doubt first of all. Sukanya says, but we did pagination, right? At a time, we do not need 2000 DB calls to be made there, right? Okay. So Sukanya, you tell me, what kind of a pagination would you want? So let's say you are designing a Facebook system. You have 2000 friends. Would you want a pagination which looks something like, okay, on the first page, you only see posts from Lokesh. Let's assume Lokesh is your friend. On the first page, you only see posts from Lokesh. On the second page, you only see posts from Beshali, assuming Beshali is also a friend. On the third page, let's say you only see posts from me. Is that a good design, Sukanya? That would be very boring, right? You would not want to have posts from only one user filling your entire newsfeed unless and until you go to the next page, right? So even if we are doing pagination, you would want to collect data from all your friends in a single page and not instead do that one page would only be dedicated to 1 or 2 or 5 or 10 or 15 friends. Okay, so even if you're doing pagination, you require all that data at your end for you to be able to do pagination, right? What better you can do? You can say, yeah, from every friend, I'm only going to ask the DB to give me 5 posts or 1 post or 2 posts or 3 posts, right? But I would not be wanting to do that. I'm not getting any post from this friend just because I'm doing pagination. I hope it makes sense to Sukanya and to everybody else in the class, right? Cool. Now, let me unmute. Neeraj, do you want me to unmute you? Neeraj, Uzair, Manish, who would want me to unmute them? Beshali, I would be unmuting you. So, first of all, who should I unmute? Anybody please volunteer? Nobody's volunteering. Nikhil can try. That's great, Nikhil. Yeah. Hey, Nikhil.
Yeah, hi Tarun.
Yeah.
So one of the basic approach which first strikes to my mind is so we can maintain a server level cache, basically app server level
App server cache. Okay. So every app server now comes with a cache as well. Okay. Yeah.
Yeah, where basically at least we can store the friend list of user ID to friend list kind of thing. So that
Makes
basically
sense. Makes sense. So everybody, one thing that Nikhil has just told us, that for every box, let's have a app server level cache, and there let's have a user ID to friend IDs ka cache, right? And now this cache can be based on, let's say you can dedicate a fixed amount of memory to this particular cache and say it's going to be LRU. Does that work, guys? So let's say you just have a LRU cache where you're going to store the friends of the users who are actually, for whom you actually require to look at their friends all the while. Okay, so let's maybe just have a LRU cache there. Okay,
yeah,
or
because
maybe let's have a
that
most
call won't
frequently
be much
used,
heavy as well.
right? So maybe let's use have a most frequently used cache there. So maybe there would be some users who do not require, we do not require to look at their friends ever, because those people do not come to Facebook, let's say.
Yeah, much
Okay,
not
so let's
actively.
have a simple most frequently used or LRU cache for maintaining user ID to friend ID. This is one thing that everybody should understand, no doubt about it. Yeah.
Yeah. So the other one which heavy call which comes up to the thing is so user ID based on each friend ID or user ID post,
Right.
right?
Right.
So that basically if we store it for a single server, then that won't be the case. That would be matching to the same server. So maybe we can use something like a global cache if it's visible or something.
Okay. So you are saying ki we could have actually had that cache not only for user IDs to friend IDs, but we can also have it for user ID to post ID. So this
Yes,
user is
yes.
making this post. Let's have a cache that way around as well. And you are saying that there are two ways to do it. One way would be to have an app server cache where all the users belonging to this app server, the post of those users will be cached at this box.
Yeah.
Okay, this is
In
one.
that, yeah.
The
And the
other
other, yeah.
is that you would want to have a global cache, and the global cache would have what kind of information, Nikhil?
User ID. So based on a particular user and post which he have posted
Okay,
in a sorted manner kind of thing.
that makes total sense. So you are saying that we can have a app server or a global cache. We are going to discuss what works, what does not work
Yes, yes.
for user ID to posts as well. Good. Now, how is the newsfeed going to be generated, Nikhil? So let's look at how the data. So so till this point in time, what Nikhil is suggesting is that clear to everybody in the class? Can you guys appreciate what Nikhil is suggesting? Cool. Now let's actually try to figure out how the data flow will happen, right? How will the data flow? एक second यार, ये कहाँ चला गया मेरा?
Yeah. So basically, I feel user ID to post for that. Basically, the global cache will make a little more sense because because one user can be friend of many users, right? And that may not be on a specific app
Box.
server or no.
Makes total sense. Right. That's a very good point. So that's a very good point. So what Nikhil is saying. So let's actually I would want to spend a lot of time on that, Nikhil. I would want everybody in the class to appreciate that very important, very properly. So let's just hold on for that a bit. You tell me that even if let's say you have a global level cache or app server level cache. Let's say you want to have a global level cache. You tell me how would a control flow look like. So you have a client here, you have a load balancer here, then you have these app servers, and then you have some storages. Can you tell me, and let's say you have a global cache here, Can you tell me how a control flow would look? Let's say I want to look at my newsfeed. How would things happen?
So basically, first of all, we'll receive load balancer will receive a request based on your
User ID. So let's say my user ID is 107. This is the request that I've got. I want to load my newsfeed. And let's say I want
pagination also can be there. But
pagination, so let's say I want to look at the first page. Let's assume.
First page, correct. So first of all, it will go to a particular server which is linked to you, which will be having cache related to you. So like friend ID and all. So it will go to that server and it will fetch. That will be already available. Friend list will be already available over there, right?
Okay, so let's assume I am taken to this box because there is where my competition happens, and most likely my friend list would be there, which may not be there, but most likely will be there. Assuming if I am a frequent user, right? I'm an active user, so I would be having a mapping of all my friends. So let's say I have 3,000 friends here, and let's say I have now the mapping of all those friends, so I know their user IDs.
So if it's not even there, it will take max 50 milliseconds to fetch it from the database.
Makes sense. So if it's not there, it will just fetch it from the DB and maybe place it in the cache if that's least recently used, or if it's most frequently used, it may or may not place it in the cache. But those are simple replacement strategies. We need not worry about that. Right?
Yes, right. So now the other scenario comes up is we need to pull the post of all the users. Basically, let's say we can have a limit to that post. Let's say
now we need to generate my newsfeed. After I have my friends, I want to look at the posts that those friends have been making, right?
Yes.
So how should I go about that?
Yeah. So what I need to, first of all, I need to do is for all those friends, at least I need to query, let's say 10 or 20 posts, somewhere around that. A number can be there. And those all top posts recently posted by those users.
Okay. Right? So this recently posted or not recently posted, these are the decisions of how would you want to sort your newsfeed, right? How would you want to create a newsfeed? It can be either based on recency, it can be either based on popularity, it can be either based on a combination of the two, it can be either based on relevance. So let's say I am somebody who is very much interested, let's say in cricket, so I would not want to be, and let's say I do not like let's say anything, there is something that I do not like at all, I would not want to see posts regarding that topic. So maybe there should be some relevancy, or these kind of different metrics for each. You can figure out that what is a good metric for you, what posts would you want to select for yourself. When you want to actually now, so we'll actually discuss that also. So it's a good topic that actually just came out randomly. I was not planning to bring it up, but there is a difference between the parameters which are dependent on you and between the parameters which are consistent for everyone. What do I mean by that? So let's say if we want to have a newsfeed based on recency, you need not worry what user is looking at. Does it make sense? So let's say if I am looking at my 2,000 friends and seeing what posts they have done, or let's say somebody else is looking at their 2,000 friends and looking at what posts they have done. If there happens to be a common friend between me and them, we are going to look at the same post from that user. Does it make sense? And does it simplify the problem?
Yes. So that's why I was,
let me just complete it again. So everybody in the class, does it make sense? So if you have a metric which is actually consistent across users, it becomes easier to save it, easier to retrieve it, easier to work on it. Let's say popularity. So if a post is popular, it would be popular for all of us, right? But let's say if you want to maintain relevancy, then making your cache in a fashion that it's relevant to you would be very, very difficult, because it would then become irrelevant to somebody else. Does it make sense, folks?
Right.
Does it make sense to everybody? The moment it also becomes dynamic, then storing your data would become very, very difficult. In fact, impossible. Then the only solution that you have in these kind of situations is to do a better job at your box. So once you get all the data at your box, you do a better job of ranking them according to relevance. You will have to reject a lot of posts, look at a lot of different posts, and then design a relevant newsfeed. But you cannot actually afford to store data differently in the cache. Does it make sense to everybody in the class? Right. So Manish is getting a lot of posts in his feed. where some of his friends are commenting on some ugly pics of some of his other friends. So, so yeah, so that may be, let's say, relevant, popular, and that's why you would be seeing those posts, right?
Yeah.
Yeah, cool. Yeah, Nikhil, you can carry on.
So basically, in that case, what we can do is, so basically in any of these cases, so basically how we'll be sorting our news feed. So that will be the one another question which I'll counter. So counter art. So let's say there are some feeds which are basically recent, based on time, and some will be there which will be based on popularity. So which to show first and all that things will also
Okay,
come
so,
into the
okay,
picture.
so that is primarily going into the algorithm of Facebook's newsfeed. That is something which is not required to be discussed in a high level design interview. You can
Okay.
actually you can actually tell them that yes, if you want to have some algorithm which takes these things as inputs, then you would want to store your data in this manner. If you have an
Yeah.
algorithm which takes these things as input, you would want to store your data in that manner. That's the only thing that you should be worried about. If somebody wants to have a discussion on what kind of a ranking mechanism are you going to use, I would not want to discuss that in today's class, but that is also a very, very interesting problem. You can actually come up with several ways of ranking a news feed by looking at several parameters, but that's not a very, very high level design system, high level system design thing to do. It's more of an algorithmic problem to solve, right?
Problem.
Cool,
Yeah.
cool.
Right.
So we have
So
discussed that. Yeah, we have discussed that. So now you have told me that you are going to fetch all the posts or some top posts of those users from the cache, right? If those things are not in the cache, you're going to go to the DB and fetch those, and then you
yes.
are going to create the newsfeed and then show it to the user. Does it make
Yes.
sense? Okay. So
Yeah,
now,
so that I'll try to put it in the global cache so that if any other, basically there's a common friend of it who's also want to query the post for him, so that can be used.
but you are not storing the newsfeed, are you?
By post, I need the newsfeed kind of thing.
Oh,
So
so this is a big doubt then. So okay, so everybody, please pay attention here. So what are you storing in your cache? So simply saying I will be having a cache is not good, matlab would not solve any purpose. What you are storing? So there are two things to store here. Everybody, please appreciate. One thing would be to store in the cache that this is the guy, he posted this. Do you guys understand that? One thing to store in a cache would be user ID to post ID. See, I am a user, let's say Tarun posted a photo of, let's say, interview bed. So let's say this is what I have in the cache. Or let's say Tarun, let's say posted a photo of, let's say a post about this lockdown. Or let's say Sukanya posted a post about, let's say, some cricket match going on. Moise posted something and so on and so forth. This is one way of caching. The other way of caching would be that for Moise, this is the news feed that he should be shown. For Tarun, this is the news feed that he should be shown. And for, let's say, Manu, this is the news feed that he should be shown. Does it make sense, people? These are two different ways of caching. How many of you understand that? This basically is caching a aggregated data, that you are caching aggregated data and telling everybody that, hey man, for this person I have aggregated all the posts for him or her, and now you have just cached the newsfeed and all you need to do is just access the newsfeed and show it to everybody. This is something which is not at all aggregated. This is something which is saying that I am only storing the fundamental data, and now I'm going to do on the fly newsfeed generation. Does it make sense to everybody in the class that these two are fundamentally different approaches at a totally right?
yes.
So yeah, so Nikhil, what approach were you suggesting?
So basically, in both of these, little trade off will be there.
Okay.
So yeah. So in the aggregation one, right? So
Mm-hmm.
in aggregation, basically we'll be so that depends how we are doing the aggregation thing as well. For first time, it will be doing pulling all the things from the DB for first time and then storing them. So
Okay.
in that case, that thing will be and then we'll have to update it as well. So after some time, it should be updated as well. And in the
Okay.
fundamental, I think that can be used in a way. So if anything is like based on single user, which all top 10 posts he have posted, that comes things into my mind.
Cool. So over the next 30 minutes or 40 minutes, we are going to discuss extensively the difference between these two. Thanks a lot, Nikhil, for volunteering. I really appreciate that. Thank you.
Thanks a lot.
Thank you. Who can I unmute now? Beshali, do you want me to unmute you? Yeah, sure. Hey, Beshali.
Hi, Tarun.
Yeah.
My design is slightly different, and it's more towards the aggregator side.
Okay.
So my suggestion is, instead of doing all of this computation at compile time, basically like cut load time or whenever we are requesting, I would probably do something along the lines of pre-generating the newsfeed in something like a newsfeed generation service.
Okay.
So that takes away all of the ranking, sorting, merging from my headache. Like that becomes an abstraction of its own, and I have to deal with now how to generate the newsfeed, store it, and basically where do I pull the data from. So I would probably prefer.
Just a minute, Beshali, so that everybody is on the same page in the class. So everyone, what Beshali just said, I would just quickly repeat that. She is saying that she would not want to generate news feeds on the fly. Instead, she would want to have a service which would maybe be running at some frequency and would be updating the newsfeed of every single user or some of the users that she will tell us. And now she's going to save those newsfeeds somewhere. And whenever a user comes, he or she wants to see his or her newsfeed, they would just fetch that pre-computed newsfeed and you will be shown. Is that right, Beshali?
Yeah, that
Everybody
is
in the class, do you guys appreciate what Beshali is saying? Right. And please be a bit more responsive, folks, right? Please be a bit more responsive. Yeah, right. Yeah, Beshali, please go on. How would you do it?
So probably I would have some sort of a data structure which would map from user ID to the feed items, to the list of feed items.
नहीं एक सेकंड क्या बोलते हैं nothing is in memory here, right? So data structure मतलब you need to discuss everything which is sitting. You need to discuss how you are going to move data from one box to other and how things are going to happen, right? So you cannot just simply say you are going to have a data structure which is going to have a mapping, right? That's not possible, right? You are not computing.
Okay, so I'll have probably a feeds ka table.
Okay.
But there'll be a feed ID along with
all that diagram if you're fine with that, right? So we have a client,
right.
Then you have that load balancer, then you have these app servers,
right.
And then you have these storages. Abhi tak what did we discuss? That the storage will have two tables. One would be user ID to friends, and
correct.
one would be user ID to friends, and one would be user ID to posts. Now you tell me what we are planning to do now.
So from the app server in between, I would have a newsfeed generation service.
Okay, so you would have a newsfeed generation service, which is again going to be using these app servers only, right? So any service going to use these app servers only. So let's assume a few of them are actually there for this service of yours, which is the newsfeed generation service. Let's assume. Okay, now what happens?
Okay, so we have some newsfeed generation services, and then on top of this we can have the cache.
Okay, so you have a cache, global cache here, or
a cache, so yeah, global cache holding feed.
Okay, now you tell me how you're going to actually, how are these boxes going to compute your news feed?
So the way I would probably set up the newsfeed would be, the way the newsfeed would be computed is with every feed, like for every user ID, I would have associated feed, right? Right, and I would also have some sort of a timestamp. Basically, what was the last time for this user? Basically, for this user, when was the last time I generated the feed?
Okay.
So using that, I can each time a new request, like every time I have to generate a feed for the user, I know that this was the last time I had generated the feed for this guy, right? So use whatever feeds I have not seen yet.
So what would you be doing, Beshali? So you would, let's say you want to generate a feed for Ankit, let's assume. And now what would you do? You would actually go to every single DB box, assuming Ankit has 2,000 or 3,000 friends and his friends are spread across multiple DB boxes. So you would be going to every DB box, fetching the latest posts, bringing them at your newsfeed generator app server, generating the newsfeed and storing that in a cache. This is what you're going to do, Beshali?
No, so I would probably store, if I'm pre-computing all of the feed for Ankit, right? I would probably store it with his user ID and a particular DB shard, right? So I would go to that specific DB shard.
So there is a lot of confusion going on. That is why I actually described that there are two different ways altogether. One is that you are storing aggregated data. The other is that you're storing fundamental data. if you want to store this aggregated data, keep what is the news feed for Ankit, even in the DB servers, right? You want to do that, Vishali, right? You want to store
Yeah, I want to store
aggregated
user ID to
news.
feed items.
Okay, so you want to store user ID to feed ID, let's say. You have built
Yeah.
a feed ID and you want, and that feed ID will be consisting of some posts in a sorted order. And
Correct,
you
correct.
now want to save that user ID to feed ID in one of the DB boxes, right?
Yeah, yeah.
Okay, now if that is what you want to do, Vaishali, you tell me, let's say now I am a friend of Ankit's. Okay, so I am a good friend of Ankit and I am posting all the time on Facebook. I am sitting at home in this lockdown time period. I don't have anything to do. I am posting throughout the day, right? So how is Ankit going to know that I am posting something, right? So I am posting and you would be storing that. I would also be sitting in one of these boxes. Let's assume I sit in this box, and in the table which was user ID to post ID, across my name, you are going to keep on adding those posts. Does that make sense?
Yeah.
Or let's say, let's actually have a normalized table. Let's not actually have a denormalized table. So let's say Tarun post 1, Tarun post 2. Let's say this is time ID 1, time ID 2. Let's say Tarun made another post because he's very, very out of business and he's just posting all the day, right? So let's assume this is what the post that you have, okay? Now Ankit should know that these are the posts that I made. Only then you would be able to utilize these posts and store a feed ID at Ankit's table. Does it make sense? At Ankit's box.
Yeah.
How would you do that? That's a big challenge now. Does it make sense?
Yeah. Okay.
Yeah.
I get that.
So everybody, whenever you actually talk about storing aggregated data, the question actually boils down to how are you actually going to reach to that state, right? Because when I am making posts, the data is not coming to you as in an aggregated format. The data is coming to you in very, very fundamental, basic unit level posts. That is what the data is coming to you as. It's your job somehow to aggregate that data and store it somewhere. Okay?
So when the data comes, so when you post, right, I will make an entry for you in the post table, in the user versus post table.
Makes sense?
Right? And then I should also probably make an entry into a feed table for all of your followers.
Okay, so now, yeah, makes sense. So everybody who is interested in what I am doing,
yes,
now,
everyone who is following you.
Now everybody who's following me, now the newsfeed generator service should know that for these 3,000 folks, this new post that Tarun made is relevant, right? And how do you actually do that? So do you actually store it somewhere? Or let's say when your newsfeed generator runs for Ankit, then you actually go to all his friends and see what they have posted, bring that to you, run the newsfeed generator, and then store your newsfeed. This is what you're going to do?
So I don't think one solution would fit here. Maybe something like a hybrid model would probably make more sense because it depends. So if I am a user who does not post a lot, right? Doing that for me makes sense, right? But if you're a celebrity or a hot type of user who posts a lot of content and has too many followers, then doing that is not very efficient.
Okay.
So based on the user type, if I can do this a little intelligently,
makes sense,
then that would probably make more sense.
I totally appreciate where you are going. I totally appreciate that there should be a distinction between what kind of a user that is, right? So you should be having maybe a different approach for a celebrity user and a different approach for a normal user. But let me just clarify one thing. So let's for now forget about celebrity users, okay? The point is that when you actually discuss a lot of things, you are bound to miss out on the very, very basic stuff that is important, right? And this is what the interviewers are looking for. So if you do not discuss the very, very fundamental things, that how the data is moving, what kind of storage you have, where are you, so at what time you are fetching data from what place and doing what. So unless and until you actually answer all those questions, this entire things look like hand waving. Okay, so let's not worry about celebrities for now. Let's forget about them. Okay, let's talk about normal users. Now you tell me how the data will be moved. Okay, you understand my question, Vaishali, or am I not?
Yeah. So for a normal user, whenever I post, what happens? That's what you're asking, right?
Right. So if I post, what happens? So if you have a newsfeed generator service for Ankit going to run, how would he know that Tarun has posted something? Right. So one very trivial way would be that whenever the newsfeed generator service works, you would actually fetch the recent posts from every single friends of his and see what are the recent posts that they have done. But the problem actually boils down to the very first problem that we saw, that this would encounter a lot of DB calls. And for everybody, it will encounter a lot of DB calls. Your system would be overwhelmed in no time, and your system would most likely go down.
Yeah.
Right? Cool. So I will take up from here, Vaishali. Okay.
Yeah.
Yeah. Thanks a lot. Thanks a lot for contributing. I really appreciate that. Thank you. Right. So let's actually take this up, right? Or do you want somebody else want to be unmuted? Should I unmute one of you? So actually discuss your approach as well, and then take all these things in a structured format. Or would you? But this is a very, very interesting thing at what we are right now, what Vaishali left us at. Let's maybe discuss this, right? Okay. So Asfar is saying we could run a service at all the times which checks the recent post done is related to somebody whom they follow or not. If yes, the user ID is added to the map. Okay. First of all, let's look at fundamentally, you are going to store data in the DBs. Is that right? Fundamentally, you are going to store data in the DB. Let's try to answer some fundamental questions now, and then see what kind of a caches can we have and how those will help us to speed up the process. Okay. The very, very good fundamental question that we are at this point in time is, do I need to store feed data at any point in time? Let's say in my DBs, do I want to store the feed in my DBs? Okay. So to answer that, everybody should appreciate that feed is not a static thing. We started with that only, right? Feed is a ever-changing thing. Does it make sense? So you tell me, would in fact a newsfeed generator, would that actually help us? Probably not. Because let's say I have set a frequency of every 5 minutes, I am going to run the newsfeed generator for every single user in the world. First of all, is that possible? Can I actually be generating news feeds for 2 billion users every 5 minutes, every 10 minutes, every 20 minutes? Maybe not, right? So you are maybe going to, let's say, have a very, very diverse, very, very large time frame in which you're going to run those newsfeed generator and update the newsfeed. But the problem would be, it would make your system very, very unattractive and very, very non-responsive to the end users. Does that make sense? So let's say all of us are very bored in this lockdown time. We are always at our Facebooks, right? So do you think it's going to be interesting for us if we just keep on reloading and getting the same feed all the time? That's not interesting, right? What does Facebook do? The moment you refresh, it definitely has a few new posts for you to see. Unless and until you happen to be a very lonely person and don't have enough friends, right? Unless and until that is the case, you would definitely the moment you refresh it, you're going to see some new posts, right? So you see that it's very, very responsive. It need not be. Or press refresh button too often. That's absolutely right, Moez. I think that you are speaking from your experience. So if you do that very often, you are not going to see new posts. That totally makes sense, right? So when you are actually, if you want to build a responsive system, so first of all, let's actually boil down to basic questions. Do we require immediate consistency here? Do we require immediate consistency here, that Manu posted something, I want to see that post right now? No, that's not required. I do not require immediate consistency. But do I require eventual consistency? Yes, I require eventual consistency. I would want to see a post that, let's say, Archit made and I am a friend of his. I want to see what he posted. I would want to have some kind of eventual consistency. So first of all, immediate consistency is not required. Not required. Eventual consistency is required. The lag or the time when you actually see a post and the difference of it from when it was made, the post was made, the lag should be as low as possible. Does it make sense? So systems which primarily are periodic systems should not be the best way to design a Facebook kind of a system. Vaishali, does it make sense to you now? So first of all, a newsfeed generator service which runs every periodic at every periodic interval is not going to be a very, very appealing thing to do. Okay? So that is thrown out of the window. We are fine with the eventual consistency, but we want it to be more responsive. We do not want the turnaround time to be too large. Okay, cool. So this is something that we have discussed now. Now let's come back to the question that we had a few minutes ago. that do we actually need to store aggregated data? Okay? Or are we fine with only storing the fundamental user ID to post ID data? Okay. The moment you say that you want to store aggregated data, what changes? I will tell you what changes. The moment you say I want to store aggregated data, the moment somebody is making a post, you need to update the aggregated data of every single friend of that guy. Does it make sense? Let's say I am making a post. And if you are saying that I want to store the aggregated newsfeed of every person in this world, everyone who is following me, that may be 3,000, that may be 10,000, that may be 20,000, that may be 500, everybody, for everybody, I should be going and making a write request. Does that make sense? Right. So if for every single post, you are no longer writing to a single source, but writing to 2,000 sources, don't you think that would be too much to expect? So what exactly you are doing? You are essentially increasing the write load 2,000 times. Is Facebook a small system to build anyhow? Or would you want to increase its load 2,000 times? You would not want to do that, right? Just a minute, guys, just a minute. Right. So all of us in the class appreciate, everybody in the class appreciates. Sorry. Yeah, Lokesh, you're right. Okay. So before actually discussing this, completing this discussion, let's do a few calculations. Okay. Let's do a few calculations and see what is the scale of the problem and why there are some bottlenecks and why those are very important bottlenecks to actually clear. Okay. Does anybody have any big doubt till this point in time? Are you guys with me? Are you guys following what we are discussing? Do you understand that how to look at a problem, how to take decisions, how to understand the things? Cool. Let's now do a few actual, let's say realistic computations or calculations, which will allow us to figure out what is the scale of the problem that we are talking about. Okay. So let's do some calculations. So we discussed that, let's say the number of users of Facebook would be of the order 2 billion. Okay, 2 billion users. Secondly, we discussed that daily active users of Facebook would be of the order, let's say 200 to let's say 400 million. Does that make sense? Cool. Now, just because I want to estimate the number of writes that are happening, do you understand it's logical to discuss the number of posts every user makes every day? Because every write is associated with one or multiple writes, right? Every post creation is associated with one or more multiple writes. So let's say, I assume that every user is going to, let's say, make 2 posts every day. Is that a good estimation? So 2 posts per user per day. Cool. Now, if I assume that, okay. So if I assume there were 2 million daily active users, so number of posts per day would be 400 million. Is that right? So you need to actually do these computations in a real interview as well. You need to actually do these back of the envelope calculations and show them that what is the scale that you're talking about. And also these calculations will assist you in taking the decisions and impressing upon the interviewer that why you took that decision. Okay. So number of posts per day would be 400 million. Now, if that is the number of posts that you see per day, can you actually figure out the number of posts that you are going to see per second? And why do I want to talk about per second? That's because every system that you design. So in your companies also, you would be hearing the term QPS. Have you guys heard the term QPS? It's called as queries per second. It simply means that what are the basic operations that you're doing per second, right? And every system that you discuss about is discussed in the terms of my system can handle these many queries per second. Okay. So just because I want to understand the queries per second, I want to understand the number of posts that are going to be made per second. Okay. So 400 million is nothing but 4 into 10 to the power 8. Does it make sense? 400 million is nothing but 4 into 10 to the power 8. Now I want to figure out the number of posts per second. Is that right, folks? Right. So it would be 4 into 10 to the power 8 divided by how many seconds in a day? 86400. Cool. So if we just solve this, Moise maybe has solved it for us, but let me just confirm if that's the right number. This will become 10 power 6. This will become 864. This will become 4. This, I can make it 4000 into 10 to the power 3 divided by 864. I can say this is 2 times 1600, 3 times 4 times. Yeah. So it should be roughly of the order 4000. Does it make sense? So Facebook would actually be seeing 4000 posts being added at every single second. Is that a small number, folks? Is that a small number? 4000 posts being added every second. And look at the systems that we are trying to design. If every single user, if every single post interests, let's say 2000 users on average, and if you wanted to store aggregated data, do you appreciate that you are going to make 4000 into 2000 requests per second, which is 8 into 10 to the power 6 per second, which is nothing but 8 million per second? Is that maybe too big? Can we avoid that? If we can avoid that, would we want to avoid that? Yes, we would want to avoid that. Does that make sense to everybody? So we see 4000 posts per second. Every post, if affects 2000 users, these are the number of writes that I'm going to see if I actually have an aggregated storage everywhere, right? And understand, writes are not trivial. You are not only going to maybe write on a DB, you are going to maybe write on the cache. Maybe you are also going to write to a replicated DB. Does that make sense? Do you guys remember that, what we discussed in the previous classes? It's never about just writing at one single place. It's ensuring that you actually end up doing a lot of sanity. You end up enforcing a lot of sanity there. So that what happens if something fails? Something else should be there to come up and solve for you. So a write is not a trivial write, right? It takes a lot of time. It takes a lot of resources. So you would not want to maybe expend all your network resources in doing these many writes, right? Cool. So we discussed that. 4000 posts per second is what we see. And there is one more thing. Actually, we will be discussing that in greater details in the remaining classes. But the traffic is never uniform across the day. So if you are seeing, let's say 400 million posts a day, it's not going to be very trivial to assume it's 400 posts per second. Do you guys appreciate that? Because the traffic generally in any system follows a bell curve, right? This entire world is filled with bell curves. Everything that you see around is a bell curve, right? Cool. So the traffic actually comes, appraisal is a bell curve. Let's say, to me, the class is a bell curve, right? Everybody's a bell curve in this world, right? So, right. So, yes. So you would see that this 4000 posts would not be the highest number of posts that you are going to see in every second. There would be periods where you would be, let's say, seeing 8000 posts or 9000 posts. We are going to figure out a way of estimating that, figure out a way of estimating the maximum load, and using that maximum load, figure out a way of figuring out, okay, how many boxes are required and what kind of things will work, what kind of things will not work. But we are going to do that in the next class. But I've given you some idea. It's never uniform. So you cannot simply assume it's going to be 4000 posts per second. It would be more than that in some of the times of the day. Okay, cool. So we discussed that. Okay, cool. Yeah. So now, just because there are so many posts that are going around, we would ideally want to figure out a way in which we can avoid doing that aggregation, right? In which we can avoid doing that aggregation. Is there anybody who would want to volunteer and share an approach now? Or do you want me to list down a few approaches and then figure out what is the best out of them? Would anybody in the class want to volunteer? Let's take a minute and see if anybody in the class wants to volunteer. Okay, yeah, so now I can list. Okay, Bishali, my question is that I would now want you guys to think about some data flows, some ways in which you are going to save data, where you are going to save data, how you're going to move data from different point from different points, at what time you're going to do that, and discuss the entire system design. So if after discussing all these things, would anybody of you want to volunteer and discuss that? Else, what Sukanya is suggesting, that maybe I can start writing a couple of them, and then maybe you guys can keep on adding or figuring out the issues or telling why it works, why it does not work, right? Cool. So one thing that I would want all of you to appreciate, that all this problem is arising. Okay. Before that, how many of you have I lost in between? How many of you are feeling lost? Anybody is feeling lost in the class? Are you guys enjoying it? Not enjoying it? Understanding what we are discussing? Yes, cool. Sukanya always has a same answer to all the questions that I ask, like these, right? Cool. So yeah, I'm assuming that everybody in the class is finding it interesting and you guys are with me. Cool. Right. So please appreciate that the problem stems from the fact, exactly, Narayan, you just preempted what I was about to say, right? So Narayan says, if we can have all the friends in a single box, a lot of problems can be reduced. How many of you appreciate that? So the root cause of the problem here is that I have so many friends. Uzair says something can't be stored the recent post. Uzair, we will discuss that. Give me some time, okay? So yeah, so the root cause of the problem was that, yeah, people have a lot of friends on Facebook, right? It's not as if we live in silos, we have a lot of friends, right? Just because we have a lot of friends and our data was sharded across boxes, my friends can sit on different boxes. Does it make sense? If I can say that, sorry, if I could have said that every single friend of mine sits on a single box, do you appreciate that a single DB query would work? If every friend of mine sits on a single box, I can just run a single DB query, get all the data of those friends from that single box and get my thing done. But just because those are spread across multiple boxes, I need to have multiple queries. I need to query every single box, get data from there, combine it, and then do something. So the root cause of the problem is that your data, or let's say your friends, are spread across boxes. This is the root cause of the problem. Right. In NewsFeed, this is the root cause of the problem. Sukanya, you are absolutely right. The problem is, so first of all, just because this is the root cause, the problem is the very intuitive thing or the very natural thing to do would be to try to solve for this problem. Does that make sense? To try to do something so that this problem vanishes, right? So that users who should matter to each other should ideally sit on a single box. Does it make sense? And there are some ways that you guys can think about it. You guys can say that maybe I would want to say that all the users who belong to one country should sit in one box. Do you guys appreciate that? Let's say ki Nikhil would be having most of his friends sitting in India only. And that's why let's maybe have Nikhil and all his friends in a box, which is in India only, right? Which is a box which is made entirely for India. So you can say that you would be doing it country wise. You can say that you would be doing it geo IP wise, or you can say, okay, I'm building a system in which the friends have shared interests. So let's say the friends would be those who actually, let's say, are interested in cricket, or let's say everybody who's interested in Indian politics would be would be a friend of each other's, right? And you would maybe want to have all of them in a single box. So maybe you can come up with different strategies, let's say interests, or so many different things, and say, I'm going to shard my data based on that. Does that make sense to people? But the problem here is, the very big problem here is that this kind of a strong segmentation is almost impossible to do. Why so? Let's maybe discuss a few things, right? First of all, in case of a real life case of a Facebook kind of a system, do you agree that Nikhil cannot have friends sitting in Russia or in the US? He of course can, right? Right. Lokesh has some friends from US. Who can stop Lokesh from doing that? Nobody can, right? So you can actually have friends which are outside your geolocation, right? You can have friends who do not share the same interests as you. So you can say, हाँ भाई वो friend है, टेढ़ा है पर मेरा है, क्या करे, मतलब even if he or she has some totally different interests, but I still may be a friend with him. So you cannot actually, it's very, very difficult to enforce these kinds of strict, rigid boundaries, because that's not very simple to do. And that's not the only problem. The problem is even more than that. The problem is the moment you try to do that, you lose out on a lot of positive things of distributed systems. What are distributed systems for? Distributed systems are for you to for you to give a very, very good way of transitioning your load. So let's say you have 10 users today. I built a social networking website. There were 10 users. All of them wanted to help me out and they were users, right? But now it became popular. Many users have joined in, right? Or let's say my service was not at all popular in the US today, but then people started joining in. Or let's say India has, as Sukanya rightly points out, India has 1.3 billion. So India has a lot of population, right? So you cannot expect that everybody who sits in India would be there in a single box. Maybe there are so many people from Delhi, I require a different box for them. How do you manage the transition of loads? How do you manage new people joining in? How do you manage people leaving out? How do you manage different in loads? The moment you try to enforce these strict boundaries, you lose out all the good aspects of distributed systems. Does that make sense to everybody in the class? So you would not want to do that. So this is an approach that I have seen several people taking in the interviews, but more often than not, this approach fails. Right? You can actually come up with a very, very specific kind of a use case in which you can say that this is what will work because my use case is very, very specific. But for real life problems like Facebook, newsfeed, Quora newsfeed, or for any real life problem that I can foresee, this kind of a system would not work. So do you guys now know one way that you should not be going in an interview? For most of the problems. Of course, I cannot make a sweeping statement that you cannot do this ever, but for most of the problems, you cannot do this. Does that make sense to everybody? Right. So let's not try to enforce these rigid boundaries. So if we cannot enforce these rigid boundaries, do you appreciate that this root cause is there to stay? That my friends are going to be distributed across boxes. I need to live with that. I can try to minimize that, but I can never enforce that all my friends will be sitting in a single box. Does that make sense to everybody? Okay, so that brings me to an important point. The important point is that even if that does not solve for 100% of the cases, still nobody is stopping me from having users based on geolocations, right? Because that at least would save some amount of calls. Does that make sense? I'm not saying that you should not do that. I'm saying that even if you do that, the problem will not be solved, may get reduced in some cases, but will not be solved. Does that make sense, people? I'm not saying that you should never do that. I'm saying even if you do that, the problem would not be solved. The root cause is here to stay. Your friends are there to be spread across multiple DBs. I hope everybody appreciates that. So this second class of approaches is not going to help you solve this problem. May help you reduce the problem, but that's all about it. Now, let's maybe discuss a couple of more approaches. Let's go again back to the approach that Vaishali said. She was saying that let's actually try to store aggregated data. Let's actually try to do that, but maybe do that in a bit better manner. Okay, guys, can we try doing that? Maybe try doing that in a thoda sa better manner of how to actually do that. Okay, so I would say, okay, so let's say this is your client. Let's say this is your client. This is your load balancer. These are your app servers. These are your DB instances. Okay, so let's say that we would still want to store that aggregated piece of information that is newsfeed for folks, but let's try to figure out a different way. So there is a client who wants to write something, that I am making a post. So you would want to call the API that write post and send the user ID and the post content and so on and so forth, the load balancer, using its consistent hashing, will take you to the box where you should be sitting. And there, let's say you make a post. Okay. The moment you make a post, so what you can do, maybe you can go to your specific DB and in the user ID to post ID mapping, add a new entry of the new post that you have just created. Does that make sense, folks? So you have just written that. But let's say along with that, you also have a app server cache at every box. Or let's say not an app server cache at every box till this point in time. Let's assume that for every box, you have a queue. You have a queue of posts coming to you. Does that make sense, people? Does that make sense? So let's say for every box, you have a queue where you can push some requests. So let's say messaging queues, exactly, Sankalp, some messaging queues. So let's say what happens. Sorry. If just because I want to write a post, I wrote the post in the DB only once, but what did I do? I figured out and I figured out all the friends that I have, right? And then I know which friend is sitting in which box. So what do? I insert a message in all the queues where a friend of mine is sitting. Does that make sense? So I would be sending a message to every single box's queue where a friend of mine would be sitting, telling them about, hey man, I am this guy. This is the post that I have made. And these are my friends sitting in this box. Maybe you would want to access this for them. Now, maybe at every box, there is a consumer running, a consumer who is consuming from this queue and is updating the news feed of that user only in the cache. Does that make sense? So I'm not storing anything most likely I'm not storing anything in the DB. I can end up storing things in the DB, but if I want to minimize the number of writes that are happening in the DBs, I can say I'm not going to write those things in the DB, but I am only going to write in the app server cache of that box. Update the news feed in the app server cache of that box. How many of you understand this? Yes, Moez, this is called as a push mechanism. You are pushing the post for everybody to look at. Okay. So Sukanya, in the DB, we are storing all the fundamental information, all the basic information that we require. We are storing the posts that are happening, but we are not storing the aggregated, the derived information we are not storing in the DB. The derived information we are, let's say, only storing in the cache. So even if the cache goes bad, I can always go back to the DBs and devise that derived information again. Does that make sense? Okay, I will repeat it. I will repeat it. So how many of you get it? How many of you did not? How many of you definitely want me to repeat it? How many of you get it? Repeat. Yes. By yes, I mean, I am assuming that you got it. So, okay, everybody's asking me to repeat it. Okay, I can do that. Cool. So what we are trying to do, we are now trying to build upon what Beshali suggested. She was suggesting that we should have, okay, sure, Beshali, I will do that. So Beshali suggested that we should be storing the aggregated piece of information as well. And we should be storing aggregated piece of information as well. And we should be, so that whenever somebody wants to look at his or her news feed, you can just look at the news feed and show it to them. Does it make sense? Right, it makes sense. Now, let's try to see what is the approach that I suggested, how it overcomes the problems that Beshali's approach had, and what are the problems that are still here, if any, right? Let's try to do it. So here is your client. The client interacts with the load balancer. The load balancer is going to interact with all the app servers. You are going to have these DB boxes here. Sorry. Now, whenever a client wants to write a post, let's say you want to write a post, right? Your load balancer using consistent hashing will take you to the box where that user's posts are being handled. And you are going to say, I want to write a post. Whenever you write a post, do you want to persist that post forever? Do you want to ensure the user that, hey man, you have posted it, I'm not going to lose out on it ever? Does it make sense? Should I be, as Facebook, should I be doing that? Or should I be saying, oh, sorry, I just lost your post? Should not be saying that most of the times, right? So you should be persisting that data without any doubt. And whenever you want to persist, you would want to use a persistent storage. Caches in general are not persistent, but yes, you do have persistent caches as well. We are going to discuss that in the coming classes, but you would not want to simply say that I've just stored that in the cache and not. Right, Bishari, you're absolutely right. That's a very, very important use case of Facebook, right? Right, cool. So you would want to actually persist the data somewhere. So the moment a post arrives, you would want to actually go to your DB and in the user ID to post mapping, add an entry there. Okay, this is the new post that I just got from this guy at this timestamp. Does it make sense? Is it fine till this point in time? Okay, if this is fine till this point in time, let's not discuss queues, Abhi. Let's actually see how this can be now used. Okay, so we have written there. Vishali, I will just come to it. Let me just complete it once. Okay. Now, when I want to look at my newsfeed, so when I want to read my newsfeed, let's say get newsfeed. Now, let's say somebody wants to get his newsfeed. Let's say the load balancer takes him to some other box. Now, he would actually have to go to every single box to see uska us box mein jo friend tha, what are the things that they have posted, and look at those posts and solve the data for you. No, solve the thing for you. Okay? This is what we could have done. But we discussed that was a very, very time consuming process. So what's better to do? Probably what's better to do is, okay. No, we did not discuss that, right? We did not discuss that. So let's say one simple way of doing this would be that you actually write to your box, and when somebody wants to generate the newsfeed, you are going to go to every single box where your friends are sitting, get the data from there, and process that data and generate a newsfeed. How many of you appreciate that? Can this be done? This can be done, right? The problem again would be that whenever you want to generate a newsfeed, you are actually going to 2000 boxes. Performance is bad, right? This is doable, but performance is bad because whenever you are generating a newsfeed. So now writing is not tough. In the previous approach, writing was made tough. Here, writing is easy, but reading is very tough. Does it make sense? Generating the newsfeed is very tough. How many of you appreciate that? Yes, you do, right? So if generating newsfeed is difficult, why is it difficult? Because I am actually going potentially to 2000 different boxes and fetching data from there and then aggregating at my place. So there is a lot of data being transferred and a lot of network overhead and a lot of DB processing overhead. Does it make sense? Now, to solve this problem, do you think if I maintain a cache, can that solve that problem for me? Would that allow me to not do so many intensive reads? Right. Okay. So Uzair says, but comparatively there will be less writes and more reads. That's a very good point to raise. Uzair is now saying that in this system, do you see that the number of posts that are generated are higher, or do you see the number of times news feeds are getting generated are higher? Is it more read intensive or is it more write intensive? It's more read intensive, right? So in fact, this design would be slightly poorer than the previous design in case of performance. But this design would be a lot better in terms of storage as compared to the previous design. How many of you appreciate that? Because here I am storing every post only once. In the previous design, I was storing multiple copies of each post. Does it make sense to you guys? So now in this design, we see another problem. Let's actually keep this here only, make some improvement here, and then see what problems are remaining, make some more improvement, and maybe go to a design which best suits this. This is how you actually should be comparing different designs. Do you guys appreciate that? Till this point in time, we have discussed two very, very fundamentally different designs, and we have understood that what is the pros and cons of both of them. I would advise you guys to revisit the lecture again, maybe at a higher speed, but make sure that you write notes and you understand what are the different things that we designed, right? Because it's not possible for me to repeat it again and again and again, right? So it's very, very important for you to revisit the lecture so that you guys are crystal clear of about what are the things, different things that we discussed. Okay. Now, we discussed this approach. We know its pitfalls. We know its good things. Now see that queue-wala approach, okay, that I was telling a minute ago. That approach was that this happens to be your client, takes you to the load balancer, have different app servers here, have different storages boxes there. Whenever a write post comes, you go to your particular box. You go to your particular box, and from there write to the specific DB that you are at, the user ID, comma post ID, comma time frame, timestamp. Usme you write your entry. But at the same time, you do something. You push this new message to all the boxes where your friends are sitting. Does that make sense? You push this message to all the boxes where your friends are sitting. Does that make sense to you guys? Does that make sense? So what do? You push this to all the boxes where your friends are sitting, or in fact, let's say you push this to every single box. You tell them, man, that I have just made this post. Okay. How many of you have some exposure to messaging queues? Azhar, you are right. You are right as well, Azhar. Okay. Do you guys understand that in queues, there is a producer and there is a consumer? Do you guys appreciate that? There can be multiple consumers, multiple producers. There can be multiple topics in any queue. Those are things that we should be discussing in more detail when we actually discuss messaging queues. But some basic concepts you guys should be familiar with, right? That it's just basically a queue where there are some things, some systems who are producing, who are filling in data in that queue, and there are some consumers sitting on the other end which are consuming data from their side of the queue. Does it make sense? Folks, does it make sense? Okay. So what are the advantages of queues basically? First of all, yes, you would want to transfer messages from one place to another. That is why you would want to maybe use queues. The second and the most important aspect is that you allow for different systems to work at different paces. Does that make sense? Let's say my producer is super fast. I can just keep on inserting messages. But let's say my consumers are slow, right? So they can actually do the job at their own time, and my producers can do a job at their own time. Of course, this cannot be infinitely extended because the queue would also have some limited amount of space. Then if your producers are producing too much for your consumers to consume at a big amount of time, then you are actually bound to drop off messages. Does that make sense, people? Does that make sense? So do not take it to the very extreme, but just try to appreciate that it may not be a one-to-one mapping any longer. It may not be that you are producing it right now. There should be some consumer sitting it right now to consume it. But even if on an averaged basis, let's say on a period of 2 hours or 3 hours, basically it allows you to account for sudden increases and sudden decreases. Does it make sense? This is what a very, very good usage of queues are. Second very good use of queues is that you reduce the number of connections that you establish, right? Earlier, let's say you want to make an API call. You would just make an API call, establish a connection, make an API call, and you cannot wait for them to respond back to you. So you can just say, yeah, I'm dropping off the connection. You write it at some DB, and I will read it from there. We discussed that in one of the previous classes, this approach. But the problem there would be that you would be requiring to make too many connections at the same time. Does that make sense, folks? That may overwhelm the system where you are actually processing those requests. So these are the kind of things that are actually solved using messaging queues. So here we could have done the same thing. The moment you want to write a post, you can write that post to every single queue. And now there can be a consumer at every box, which can be consuming those messages from the queue and updating the feeds of all the friends that are in that box. Does that make sense? Does that make sense? Yes. So Neeraj asked, what will the queue contain? It will contain user ID, post ID, time ID, timestamp. Does this queue thing make sense to everybody in the class? Very few of you are replying. To whom it does not make sense? Suhail, yeah. Suhail, I'm not saying that this is the best solution. I'm just saying that does this solution make sense? Yeah, Vaishali. So you are still writing to every follower. You can do that. I would, in the next iteration, I would tell you a better approach in which you can avoid doing that. Does that make sense, Vaishali? Okay, so let me just just because I'm seeing 5-6 doubts I've seen, let me just ensure that I repeat the data flow again so that everybody understands it, because rather than answering all these doubts individually, it would be better for me to explain the data transfer again. So what I'm saying is that, does everybody understand that whenever a post is made, you will just go to your specific DB and in the DB update the user ID, post ID, time ID, add an entry there. Is that right? That is right. Now, does everybody in the class appreciate that you can now just add a copy, maybe a user ID to a post ID mapping in every single queue of every single box? Do you think that can be done? So you have just basically notified everybody that I have just made a new right? I've just written a new post. Now, at every box, there would be one consumer or more than one consumer who would be just consuming that post that was just created. And now using that post, updating the news feed of every single user that is sitting in that box and storing that updated news feed in a cache. Does that make sense? Right. Lokesh, there are so many problems here as well. I will discuss that. But let's see if this solution makes sense, and let's see what are the problems that this is solving. I'm not saying that this is the best solution available. Okay, cool. So now you can actually understand that how the data flow will be there. Does it make sense, guys? Okay. Now let's look at our problems. Let's look at the problems that we have. Yes. So Abhishek is saying, so for the consumer, we need to know the user ID, friend ID in that app server. Yes, Abhishek. We already discussed that at the very beginning of the class when Nikhil was unmuted. He suggested that we should have a cache where we can actually maintain the user IDs to friend IDs. So that is something that you should be doing. And if that is not present in the cache, you can always fetch that from the DB and put it in your cache. Does it make sense, Abhishek? So that is because that's a very, very trivial information to get. That's just a 1 DB call. Even if it's not present in the cache, that's just a 1 DB call. Does that make sense, everybody? Cool. So this system will work. Now let's look at the problems that we have. First of all, look at the solutions that this system is providing. First solution is that your DBs are prevented from so many writes. Does it make sense? Your DBs, you're only writing the actual fundamental information, the basic information in the DBs. You are not writing the copies in the DB. So your DBs have been saved from all the insanely high requests that were coming in the previous approach. Is that clear to everybody in the class? The very first advantage. Okay. Let's look at the second advantage that it has over the system that Vaishali came up with. Vaishali's system was not very responsive. Does that make sense? So people would be able to see their updated news feeds very after a long amount of delay. There was a huge delay in that system. Here you would be seeing that the delay is very less. Does that make sense, everybody? Here the delay is very less. Now let's come to the problems. The problems, the very first problem would be that you are having a lot of writes here still, not the DB writes, but you are still transferring a lot of data over the network here. Does that make sense? Your network may be choked. Your network may very well be choked. And you are actually maintaining a lot of duplicate storage as well. So that's again a bad thing. Okay. But still, I would suggest that this is a much, much better system than all the systems that we discussed till now. Does that make some sense? And do you appreciate that this is a push-based system? That the person who is responsible for sharing the data with everybody else is pushing that data, and now you can consume that data and update your specific data frames. Okay. Now I would want to open the class for some comments. I would want you guys to think about its positives and negatives and let me know that you are willing to volunteer. I would unmute you one by one and see how you are perceiving this design. What are your positives that you can think of? What are the negatives that you can think of? Sukanya is asking the question in the meanwhile that whether you should be pushing that to all the queues of all the boxes or only to the boxes where your friends sit. Sukanya, you can push it only to the boxes where your friends sit, because pushing it to the boxes where your friends are not there does not make any sense. So, but in the worst case, you would be actually pushing to every single box. Okay. Archit has a question. How consumer find specific friend to show the post? I did not get your question, Archit. Do you want me to unmute you? Archit? In the meanwhile, are you guys thinking about it? Or have I lost you in between? You guys are thinking about it, right? Archit is. What about others? Yeah. Okay. Cool. Archit, do you want me to unmute you? Okay, you got it. Okay, cool. Right. Cool. So think about it and maybe take it as a homework exercise if you want to take some more time. If anybody wants to volunteer, you can volunteer right away. Else you can take it as a homework exercise, think about it, go through it properly, and then get back to me and let me know that what else you could think about it. Okay? Can we move ahead, people? Yeah. Shubham, do you want me to unmute you, Shubham? Shubham, do you want me to unmute you? Rather than typing, you can just ask me to unmute you. Aswar, I will read your comment in a moment. Let me just unmute Shubham. Yeah, Shubham.
Yeah, hi Tarun.
Yeah, hello.
Yeah, so the pros is that like this might work if we do not have too much of load.
Mm-hmm.
But the cons is that like we have data redundancy here, a lot of it.
Mm-hmm. So you're actually consuming a lot of, you're actually writing to a lot of queues. And when
Yes.
you are consuming, you are updating the caches, you're updating the news feeds of every user. The problem would be that so many users may not even be online. Does that make sense?
Yes.
So everybody, can you guys appreciate that? So let's say if I am pushing it to every single friend of mine, a lot of them may not have actually opened Facebook for the last 14 days. I may be just updating their cache and then just saying that nobody's coming to fetch it. And I'm just doing some job which is of no use. Does it make sense? Can we actually solve for it? Shubham? We can actually solve for it. The way to solve for it would be that if, for example, I already know that this user has not seen, or let's say there is no entry of news feed of this user in the cache, I can just drop that message off and not do anything. Does that make sense?
Yes.
Does it make sense to everybody in the class? That I can still solve for it. I would still be required to pass that additional data to every queue, but the consumer sitting in front of every queue can make that wise call of not updating anything in the newsfeed as a newsfeed in the cache, and not maybe taking the common cache resources which somebody else could have used, and maybe not wasting time computing. Does it make sense to you, Shubham? And does it make sense to everybody in the class?
Yes.
I'm waiting for you guys to reply. Yeah, Shubham, it makes sense to you. That's good to know.
So the thing is like if we had not done this, then maybe like the queue would not have been able to handle so much of load also. But like if we do this, like then it might be manageable, but still there are chances of overflow because we are not sure of how much like we'll be able to wave off. So we still have to maintain a huge queue in that in some scenarios.
Makes sense. Makes sense. But still, let me tell you, that is still that is going to be manageable. It's not going to be something which is totally not manageable. Okay. Any other con that you can think of?
No, only these two for now.
Okay. Thanks a lot for volunteering, Shubham. You are absolutely right. Okay. Thank you. I'm just okay. I'm just क्या बोलते हैं, getting away from my seat for a minute. I will just be back in a minute. Okay. You guys think about it in the meanwhile, then I will be back. Yes, people, I'm back. Okay, so I just read Aspar's comment. I am a little confused between post ID and the actual post text. Are we storing actual post text in the DB or in the CDN? Okay, a very good question to ask. So everybody, just reply to that question. Do you think it's good to decouple the post ID and the post? Do you think it's good to just be passing post IDs all across the system and not be passing actual posts? There are 2 yeses. What about the others? How many of you feel that's a good way? That's a good thing to do. Decouple post and post IDs. And how many of you think that's not a good way to do? It's definitely a very, very good thing to do, right? You would not want to pass your entire post all across. So what is a post, right? A post. Okay. So a post will contain text. With text, it will contain some images or some videos. Does it make sense, everybody? A post would contain some text, some videos, some images. Now, let's assume the number of characters in a post on average is 500 bytes. Is that a good assumption to make? Maybe 500 characters, 500 bytes. Cool. And assume the image and the video also to only be a link. Because as we discussed in the last class, these things are not stored in the DB. These things are stored at file storages. Do you guys remember that? These things, okay, do not confuse CDN here. Okay, wait. CDN is just a cache. I told you guys, CDN is not your ultimate source of truth. It's not the persistent storage that you're looking for. Do you guys appreciate that or not? Are you guys still confused with that? CDNs, never say that you're going to store data at CDN. Just tell them that you're going to store data at S3 or any file storage, and then you are going to have a copy of that across CDNs. You're going to serve data through CDNs. Does it make sense? People, I would be very, very unhappy if you do not appreciate that difference. So CDN, you would never want to persist your data on CDNs, right? Okay. So what we will do, we will store the images and the videos here at the file storage. Every other content, that is text information, including the link to the images and link to the videos, would be stored in the normal DB, where there would be a table for every post ID to post content. Does it make sense, everybody? Does it make sense? So Asfar asks, how efficient or inefficient? Asfar, what is this regarding? Do you want me to unmute you, man? If you want to have a discussion? Yeah, let me unmute you. Hey, Asfar.
Hi, Tom. Question here is that, okay, a post can be made up of 3 or 4 types of content. Okay, it can be text, it can be image, it can be video or whatever. Okay, the image and video, that is the static content, is there in the file storage. And as you tell that the text could be stored in the DB. Okay. Now let's say that one post is relevant to 1,000 users. Okay. So effectively, when those 1,000 users are looking to see their news feed, so the same content is being queried 1,000 times from the file system as well as from the DB.
Makes sense. Cool. So let me just clarify that. So you are going to, in this design, unless and until we add a cache layer there as well, I will. So wait for the entire design to complete. You will see a lot of caches being added at a lot of places before the picture becomes complete. And maybe that will not happen in today's class. In the next class, it will happen. But you will see that the system will work very, very efficiently when everything falls in place. But for now, the images and the videos, assume those are going to be served through CDNs. Does that make sense? That's a big amount of data. You're not going to essentially serve it from your file storage. You're going to serve that through CDNs. You're only going to move it from the file storage to the CDN only once. Does that make sense, Aswar?
Right.
So that, which is a very, very big amount of data, is only going to transfer from CDNs. That is totally out of your control. That's CDN's job. And even if you cache that at your app server, that would not have been the best way of going about it, because transferring this big amount of data from your app server to every user would be very foolish and also would take a lot of resources on your app server to store it, right? So, जो big chunk of data है, जो images हैं और videos हैं, that is stored, that is served through CDNs. That is a problem which is sorted. Now for the text information, right? If we actually only pass across post IDs across the boxes, just because we do not want to store this duplicate 500 bytes at every single box, at every single place where I'm referring to the same post, the benefit is that I am saving on the storage side, that I am not making my cache very heavy just because I'm storing 500 bytes for every post. But now I'm just storing a post ID, which would just take a few bytes, right? But the problem there would be that, yes, whenever somebody wants to access this data, which is 500 bytes, I would be hitting again to the DB and getting that data. Okay, but let me just jump the gun and tell you the best way to do that. The best way to do that would be that you have a separate cache which caches the post ID to post content. Does it make sense? So you are going to pass post IDs only all across your systems. But whenever somebody wants to access that post, you will just have a mapping, you'll just have a cache which will be caching the post ID to post. And whenever somebody wants to access that post, you will just fetch that from that cache only. So what do? You have in fact managed to reduce the data duplication, and at the same time you have managed to increase the availability. That is, you have reduce the lag, reduce the time it takes to fetch that data. So you have solved for both the things. Does it make sense?
Effectively, if I'm supposed to go into the terminology here, the post that I'm making at Facebook, that is somehow my transactional data, right?
Okay. Transactional data. So do you know what transactions are?
Yeah, I mean, not in the conventional way, but see, one kind of transaction is that I'm trying to access some data that somebody has posted. Okay.
Okay.
Then I'm actually
I fail to understand why you are going in transactions here. I do not.
I'm going there because if I go there, then I'll be understanding that all my transactional data or all my profiling data is actually staying in my cache layer. Then what kind of data am I going to store in my DB layer?
Okay. Okay. So we are storing the actual basic data. We are storing the key. This user has these many friends, these all friends. This user made these posts. This post ID corresponds to this text. This post ID corresponds to this video link. This post ID corresponds to this image link. This post ID had these many likes, these many upvotes, these many shares, and so on and so forth. All this information would be there in the DB. You want that information to persist for sure. You cannot afford to not have that information in the DB. The question for every derived information that is there. What is derived information? Information that you can derive from this basic information at your own will whenever you want to derive it. But do you would want to store that derived information also across the DBs is the question that we are trying to answer in this class. Aswat, does it make sense? So we saw that storing that information, that derived information in the DBs would not be the best way of going about it, because we are going to engage a lot more writes and a lot more load on the system, and we would preferably want to avoid that. Does it make some sense, Aswat, now?
Yes, it does. It does. But one question here: would it be safe in that scenario to say that my cache layer would be more extensive than my actual storage? Because
it is also storing the derived data and
yes,
not only the basic.
Yes.
Right. And that's a perfectly good system to have. So let's say just because let's say a cache is not persistent, right? So even if you lose out on that derived data, it's still fine, right? You can still regenerate it. So let's say what happens. Let's say you had a post, you had a user news feed of a particular user stored in the cache. You did not store it anywhere else, and now just because you will have to evict things from your caches all the time, and let's say you happen to evict that somewhere down the line because the user was not very active, and he or she comes back. Okay, when he or she comes back, then you can actually regenerate that cache, regenerate that newsfeed again, because you still happen to have all the basic data stored in your DB, right? And if you regenerate that, so you may see some lag there, but the point is that is totally acceptable. So I will give you a real life example. So you would have seen that, right? So let's say you are using your Facebook, you are loading your feed, and you are getting all the responses very quickly. Is that right? That happens, right? But let's say you happen to scroll it way below and you keep on scrolling, you would see that every next scroll takes a lot more time. Have you seen that as well? Right. So why does that happen? That happens because there is a layer where you have the derived information stored right away. You can access that, get that information very quickly. Then there are hierarchies. There would be another layer of cache which would have some old data. That cache or that storage layer would be slightly slower, would be bigger, would enable you bigger storage, and you would then fetch data from there. Then there would be another layer of cache or another layer of storage, where again it would be having some more data and some more access time. So what happens? You will just keep on pulling data from that hierarchy, right? That hierarchy can be 2-level deep, that can be 3-level deep, that can be 4-level deep. That is not very important to discuss in a real classroom environment, because abhi to we are discussing concepts. That is something which is very very practical, and it's only applicable for systems as big as, let's say, Facebook's, or let's say Media.net's, or let's say Google's, where you see a lot of requests happening at real time. And then you would want to have those hierarchies where you keep on increasing the access time and keep on increasing the storage. So इसमें ऐसा होता है, मतलब we all have seen that, right? When we actually keep on scrolling the newsfeed, the next page comes at a lot slower speed. ठीक है? So this is totally fine. Matlab, you can say, and you can even hit a place where that derived information is no longer stored. You will actually have to go to the actual DBs, fetch the data, derive it again, and then show it to you. That's also totally doable.
Okay. Okay. Thank you.
I hope I clarified your doubt, right, as well?
Yes, thank you.
Hello?
Yes, thank you. Thank you, sir.
Okay, okay. You're welcome. Okay. So can you repeat post ID to post data cache? Yes. So the question that Aswar had was that we are talking a lot about transferring posts from one place to another. Is that right, Nikhil? We were talking a lot about transferring posts from one place to another. His idea was that just because we are creating a lot of copies of posts, is it even, does it make sense to actually create copies of the entire post, or does it make sense to only create copies of post IDs? That is, let's say, what does that mean by creating copies? So first of all, you are actually going to use more space at every place because you're storing duplicate things. Secondly, you are going to actually cause a lot of network overhead, because in every call that you make among servers, you're going to pass the entire post, and your network overhead would be several hundred times more when compared to only passing the post ID. How many of you understand that your network overhead would be several hundred times more if you actually pass the post and not the post ID? And also your storage would be several hundred times more if you pass the post every time and not the post ID. So to actually solve for that, we would actually want to decouple the post and the post ID. Well, decouple may not be the best thing. We would actually may not be the best word to use here, but we would actually want to say that I'm not going to keep on passing the post. Instead, I'm only going to pass the post ID, because that is a reference which talks about the very same thing. Now, the problem with that approach is that if I'm only passing post IDs where I'm actually storing the post, the solution to that is that in a DB, just have one more table, which will be a post ID to post content table. And of course, post content is not going to be a single column. It is going to be containing multiple columns like text, like image links, like video links, like let's say number of shares, number of likes, and let's say the timestamp, and so on and so forth. Okay. So in that table, you actually maintain those entries. Now the problems that still remains would be that just because a lot of users are going to look at this post, and if I'm only storing the actual post in the DB, so a lot of fetches would be happening from the DB. How many of you understand that? How many of you understand that? A lot of fetches would actually be happening from the DB. So for that, one thing is that do not overestimate the problem. The problem of fetching is only fetching the text and the links of the images and the videos of links of the videos. It's never going to be of fetching the image itself, or never going to be of fetching the video itself, because the video and the image is anyhow stored in S3. Let's not call S3, let's call it file storage. We discussed that in the previous class. Why would you want to store videos or images in file storage and not to store that in DBs? We discussed that. I hope you guys remember it. So anyhow, we have those things there, but just because those things are very heavy and are usually static for a lot of users across, those things are actually not served through S3s also. Those things actually are served through CDNs. Okay? What are CDNs? We discussed that extensively in the last class. We just have a copy of those resources all across the world, and wherever the user is sitting, there would be a server of CDN sitting right next to it and serving that resource from the CDN. Does that make sense to everybody? And if you do not want to serve it through CDNs because that video is specific to a particular user, you can very well serve it from S3. That's totally fine, but that is not a big concern. Does that make sense to everybody in the class? Is there anybody who is feeling left out? I hope it makes sense, right? Now Nikhil says, but the number of posts in the post table is also very large. That's also very true, Nikhil. So again, you will have to shard that table across multiple boxes, and you cannot have only a single box where you have that table. Does that make sense, Nikhil? Cool. Would you guys actually want me to stop right now? Because we have discussed a lot of things and I would want you guys to digest it. Go through the videos at least 2-3 times. I would suggest that at least go through it 2 times. The next class, okay, Uzair is confused. Uzair, I will take your question. Do not worry. I will take your question before I end this class. But do you guys overall think that we should stop it here now? Right. So even if we have not reached a logical conclusion, but we have not left so many threads open, that if you just revisit this video, you would get a lot of sense. I hope that that is the case. If you want me to maybe spend some 5-10 more minutes to tie up some loose threads, I can do that. But I feel that we can end here as well. We have discussed several things. This is not the best design yet. We are going to come to it in the next class. But look at all the designs that we discussed today. Revisit the video. Look at all the pros, all the cons, and try to make sense out of it. Okay. Archit wants me to maybe summarize it a bit using 5 minutes. Okay, Archit, I can do that. Before doing that, let me unmute Uzair and see what is the question that he has. Hey Uzair, I've unmuted you, Uzair. What's your doubt? Uzair, can you hear me? Can others hear me? People, can you hear me? Yes, you can. Uzair, is there any issue with your mic? Okay. Oh, you don't know? Yeah, but we can't hear you, and I think nobody can hear you. Okay. Yeah, so you have posted it out. When the consumer consumes from the queue, will the consumer in the app server will update all its users or only the users? Yeah, Uzair, it will only update the users where that updates make sense, right? Let's say I am not a friend with you on Facebook. And let's say we don't have any common friends on Facebook. Let's say we don't have any common interest on Facebook. Let's say we happen to be very, very different persons. So now if I am making a post, would you be worried about that? Or if you are making a post, would I be worried about that? No. So why would the consumer worry you just because I made a post? You would not be worried, right? So you would only want to update the users where there is a connection. It can either be a friend connection, it can be either be a friend of friend connection, it can either be a common interest connection, and the connection can be something which is described by the problem statement that you're trying to solve. But you would not want to update every single user just because they happen to be on the same box. Does it make sense, Uzair? Cool. Thank you. Okay. So now, okay. Yeah, sure, Vaishali, I can unmute you. Yeah, here you go. Please tell me. Why I'm not. Yeah, Vaishali.
Okay, one basic question, Tarun. So when I'm at the application server, and I have a user ID, right? Right? How do I know which DB to go to? Every application server is maintaining a cache. Okay, this range of user IDs mapped to this DB.
No. So again, you are going to do this using consistent hashing. So we discussed that, Vaishali, in the very first class or maybe in the second class, that maintaining a mapping never works in scalable systems. Why? Because you can always see a lot more entries coming up. You can always see entries dying down. You can always see boxes coming up. You can always see boxes going down. Even though DB ke liye, you would not want to see boxes going up, boxes going down. You would want to always have a follow-up box or a backup box which can come and replace the box if it goes down. But still, you would want to actually figure out where that actual user sits using consistent hashing, and not by maintaining some ranges.
So I would use consistent hashing both for knowing which server to go to and to know which DB to go to.
Theoretically, yes. In practical purposes, you can just maybe have a fixed hash, which will allow you to go to a fixed box. But for theoretical purpose, or maybe to say an all-encompassing solution would be that yes, you have a consistent hashing there as well and there as
well. Just one more follow-up question. So we have been trying to solve this problem of newsfeed. Okay, so now if I ask a very basic question, okay, fetch my friends, fetch a particular user's friends. So for this, am I maintaining an adjacency list of all of my friends for my user ID and going to every box and trying to get everyone's emails?
No. Okay, cool. Makes sense. So you are saying that would you only be maintaining user IDs at your box and then to fetch the email Would you
So
actually?
my problem statement is very simple. Say I have thousands of friends.
Makes
I
sense.
want to see सबका email ID. So I have maintained the mapping of user ID to user ID, या adjacency list of IDs. Friends are distributed across boxes, but मुझे सबका email का data चाहिए.
पहली बात तो यार, if you have thousands of friends and if you want to look at all their email IDs, you are a very, very free person. You should not be doing that. But anyhow, even if you want to do that, so this is how your system would be handling that, right? So let's say you have this is your client, right? This is the client where you want to access your information at. The client actually goes to the load balancer. The load balancer will take you to your particular box. We already discussed that we are going to have a cache here, which is going to have your user ID and the user IDs of all your friends. Does that make sense?
Correct.
Right.
This part
Now you want to look at some further information about those friends. So let's generalize that problem. If you're actually going to look at some further information, let's say you want to look at their friends, or let's say you want to look at what is their name, what is their age, what university they work at, they are studying, where do they work at, and so on and so forth. If you want to fetch all that information, most likely you will have to go to their boxes and fetch the data. The point is you understand these things are very, very easy to cache. You can just introduce a cache ka layer there and say, yeah, these are the kind of requests that I see all the time. I can just like you add some masala in a food that you are cooking, you can just throw in some caches that would allow you to serve most of the requests most of the time. Okay? But at the same time, your caches are not designed to serve those requests all the time for all the users. So you're bound to go to those boxes and fetch the actual information. So what is the best way to answer that? I would say that you are always going to have a combination. In a real-life system, you're always going to have a combination of a cache and a real actually going. But in a real-life system, you have multi-levels cache. Okay? So whatever request you see is happening quite frequently, and you are actually going to follow a long route to get that information. You throw in a layer of cache there. Okay? Right. But it's not that simple that you will start your system design by throwing in caches all around. If you end up doing that, you will not be able to design a good system. And for sure, if you talk from an interview perspective, you will definitely be rejected because it will seem as if you do not understand anything and you're just throwing around caches. So from an interview perspective or from a real life system design perspective, it's good to understand the real control flow. Start with the meat of the problem, see how would you solve that problem. And then once you have built that system, whatever you feel is being repeated, whatever kind of requests you feel are being repeated, you just follow that 80-20 rule and you say that 80% of the requests are going to be from that 20% of data. So let me just cache maybe 10% of data and handle 72% of the requests. Does that make sense?
Yeah, fair enough.
So to answer your query, yes, you are going to have caches where you can see that कि अच्छा इस user का ये user ID है, इस user ID का ये email है, या फिर इस user ID का ये name है, या फिर इस user ID का ये age है. But that cache is not going to be exhaustive, of course, because caches by definition are not exhaustive. They follow that 80-20 rule. What is that 80-20 rule? Let me just tell you guys. 80-20 rule says that in real life systems, 80% of the requests that you see are handled by 20% of the data. Okay. Or let's look at some other variants that you would have seen in your companies, people talking about. So let's say 80% of the results come with 20% of the efforts, and so on and so forth, right? So things do actually follow the 80-20 rule. That is what the caches exploit, and you would want to cache that 20% of the data to handle 80% of the requests. But understand that the caching problem is not that simple. But those are extra levels of caches. The original problem discuss कर रहे हैं कि what to cache. Do you want to cache the aggregated information? Do you want to not cache the aggregated information? Do you want to store the aggregated information? Do you not want to store the aggregated information? What do you want? Where do you want to store? What do you want to store? These kind of data, these kind of things are very, very important. Start your question with those and then add caches wherever you want to add. Okay? Okay. Does it make sense, Vishali, overall?
Yeah.
Okay. Thank you. Yeah, so Sukarna, that's a very good outcome of this class. If whenever you open FB, you are going to think of the system design behind that. That's a very, very good outcome of these classes. So whatever system you see around on the internet, just try to understand how that would be designed, how things would be working, what would be served using caches, what would be served using DBs, how data would be sharded, and so on and so forth. So always try to think about that. If you keep on doing that, you would be you would become very, very proficient at system design, and you would understand how to do those trade-offs very well. Cool. I think we should end the lecture here because it's 11:45 already. Is it fine if we end the lecture here? People, is it fine if we end the lecture here? Any other doubt? Cool. Did you guys enjoy the class? Cool. That's that's great to know. Okay, cool. I also enjoyed teaching a lot. See you guys again in the next class. Bye. And please make sure that you go through all the go through the video again. If you do not go through it, you are bound to lose out on a lot of things that we discussed. Okay, do not do that. Okay, make sure that you go through the video, and not only today's, but make sure that you go through all the videos multiple number of times so that the concepts are crystal clear. And in the follow-up lectures, you can always ask doubts from the previous lectures. So if you revise a video, you have some more doubts that you could not ask in the previous class, you always feel free to ask that in the subsequent classes, and I would be happy to answer those. Okay, cool. Bye everyone. Good night. It was nice interacting with you. Bye.